This is Mission Control Houston. We are 14 hours and nearly 50 minutes into the NASA's Boeing crew flight test mission. The crew's asleep right now. They're expected to wake up in less than 3 hours. You're getting a live view of Mission Control as flight controllers are continuing to monitor the mission and make a plan for the day. In the meantime, why don't we talk a little bit about the cargo that's on board the Starliner spacecraft. Dee, can you tell us a little bit more about that?
Sure, Chelsea. So in addition to our most precious cargo, which are Butch and Sunny themselves, we're flying about 760 pounds, give or take a bit. Excuse me. That encompasses 26 Boeing cargo bags and 11 NASA cargo bags. So there's a plethora of each, all totaling almost 800 pounds. It's going to weigh a little bit less on the way home than it does on the way up, depending on what station crew and Butch and Sunny and ground teams deem most appropriate to bring home. But on the way up, we've got some fun things for the Starliner employees and crew themselves, like what you see here. So that's the Starliner mission patch, and it's a tradition in spaceflight to fly patches for employees. These are challenge coins that you see here for the CFT mission, and silver Snoopies, which is the highest honor that can be bestowed upon a person in the aerospace industry. So it's fun having those go to space and then be awarded to somebody that works in the space industry. And here is cargo being installed for the CFT mission. That's a water carrier going in. So drinking water obviously is very important for the crew because you can't just turn on a sink tap inside the vehicle. So things that the crew might need with them on their way up to space station, we have to pack for them.
And there was a pretty last-minute addition to this cargo, right?
There was, yes. So late at NASA's request was urine processing assembly. So the processor is actually the first step of the station's water recovery system, and it's an essential part of keeping ISS fully manned at all times. So the pump, which can be replaced while on station, failed a couple of months earlier than expected. And so a late request was made of Boeing, and Boeing was able to accommodate it. It was about a 140-pound addition, and so we did have to swap out other non-essential cargo bags, but Boeing was able to accommodate it. And this happened just a couple of days before launch, while Starliner and the Atlas V were already at the launch pad. So it proves the flexibility of Boeing's Starliner team and the ability to fulfill last-minute requests from NASA as a commercial crew partner.
And of course, the International Space Station does have quite a bit of reserve. So the station crew up aboard the space station did not go without water. So they still had that, but I know that they're looking forward to getting this part delivered to them. Happening later today at 12:15 p.m. Eastern Time. That's when we expect the docking of our Starliner spacecraft, and we're still on time for that. you're just joining us this morning, we are live in Mission Control at NASA's Johnson Space Center in Houston. We are in the White Flight Control Room, which is the command center of the Starliner spacecraft. Just down the hall, we have the International Space Station's Flight Control Room, where people are keeping an eye on the station crew and all of the station systems. Earlier yesterday, on June 5th, we had the launch of the Starliner spacecraft at 10:52 a.m. Eastern Time. Everything going well with the ascent. It successfully completed its orbital insertion burn and has been in orbit ever since. The Starliner spacecraft is making its way to the International Space Station with NASA astronauts Butch Wilmore and Sunny Williams. The teams here in Mission Control have identified 3 helium leaks on Starliner, 2 of which are new since the spacecraft arrived in orbit. 2 of the helium valves are now closed, which the crew worked before going to bed for the night. The spacecraft is stable and the crew remains safely asleep. The teams will continue to evaluate the data and are working through it through the night. We're pressing ahead for a rendezvous and docking. However, we have a number of milestones to get through before that can happen, including a couple of burns to help Starliner catch up with the space station. And here in Mission Control, Boeing and NASA will enter into integrated operations, and Starliner will pass through the approach ellipsoid, pausing at various checkout points, getting closer still, and moving through the keep-out sphere, leading to an eventual docking at approximately 12:15 p.m. Eastern. There are a couple of docking windows just in case 12:15, for whatever reason, doesn't make the cut. But there's multiple opportunities planned into our timeline today. The station crew will be there to monitor Starliner's arrival. We are just over 15 hours into this mission, and we expect our crew to wake up in about 2.5 hours from now.
Okay, for a bit more information and context on those burns we have coming up that Chelsea was talking about, take a look at this.
teams here in Mission Control are continuing to monitor the mission, and we'll stay live with our on-air commentary through docking. But in the meantime, we're going to take a look back at what happened yesterday with the launch. Mission Control Houston. We are live in the White Flight Control Room. This is the Starliner spacecraft's flight control room. Also here in the building, we've got the International Space Station's flight control room, where they're getting ready to start their day as well as getting ready to receive the Starliner spacecraft. We're still on track for docking at 12:15 p.m. Eastern Time. Here in the room, flight controllers are continuing to keep an eye on the Starliner systems, as well as keep an eye and make a forward plan on those helium leaks that were detected earlier on in the mission. So Starliner is currently catching up with the International Space Station. It's a little less than 4 million meters away. That's about 2,050 miles from the International Space Station, so quite a distance here. We've got quite a bit of time until our next upcoming milestones. The milestones, we've got our crew, Butch and Sunny. They're set to wake up in a little less than 2 hours. Shortly after they wake up, they're scheduled to have a conference talking here with Mission Control here on the ground. Mission Control's been kind of talking about or consulting with all of the various console positions, make sure that if someone has a topic that they want to bring up with the crew, that they can go ahead and do so during that conference. We're also looking forward to moving into integrated ops. So this is the International Space Station team, the Boeing team, the Starliner team, all working together. This is in less than 6.5 hours that this is going to be happening. That's when we can really start to get into our milestones in a quicker procession. For instance, we've got some upcoming burns as well in just over 6 hours that we are looking forward to as well. International Space Station is flying over the South Pacific Ocean with Starliner catching up. It's about 2,000 miles away from the space station right now. It's going to conduct a burn in about 6 hours, a series of some more burns to fine-tune its path to the International Space Station. And we'll hear a little bit more about those and what they do a little bit closer to the burn time. In the meantime, the crew is going to wake up in about an hour and a half, and teams here in Mission Control are working on their updates. We're likely to hear some chatter once they wake up with some updates that happened when they were asleep. It was possible earlier in the night that if anything came up and we needed to wake the crew, that was entirely possible and something that they could have done. However, that was determined to not be needed at all, and we let the crew get their full 8 hours. So we expect to hear from them in about an hour and a half. Maybe a little bit later after they've had their time to wake up and go into their post-sleep period as well. But we're still on track for a docking at 12:15 p.m. Welcome to the White Welcome to the White Flight Welcome to the White Flight Control Room. We're inside bring you live coverage of the NASA's Boeing crew flight test. I'm NASA Shaniqua Vereen.
And I'm Dee Dobson.
Dee and I will be with you guys for the next few hours, bringing you coverage of the Starliner mission as it's chasing down the International Space Station. NASA astronauts Sonny Williams and Butch Wilmore launched aboard an Atlas rocket on Boeing Starliner spacecraft at the Space Launch Complex 41 at Kennedy's Space Force Station. Say that 10 times fast. The duo is now 16 hours into a 24-hour flight to chase down International Space Station. We'll take a look at some launch day highlights.
If you're just joining us, welcome to the White Flight Control Room here at NASA's Johnson Space Center. I'm NASA Shaniqua Vereen, and I am joined by Boeing System Engineer Dee Dobson. We will be with you for the next few hours to bring you live coverage of NASA's Boeing crew flight tests. NASA astronauts Butch Wilmore and Sonny Williams had a successful liftoff aboard Boeing's Starliner spacecraft on a United Launch Alliance Atlas V rocket from Space Launch Complex 41 at Cape Canaveral Space Force Station in Florida at 10:52 a.m. Eastern Time. The duo is now 16 and a half hours into about a 24-hour flight to chase down the International Space Station.
At this time, the crew is in their sleep period following a busy day of certification checkouts. The teams have identified 3 helium leaks on Starliner. One of these was previously discussed before flight along with a management plan. The other 2 are new since the spacecraft arrived on orbit, but to manage these leaks during the crew's sleep period, 2 of the affected helium valves have now been closed. The spacecraft is in a stable configuration as teams continue to evaluate the data they see while monitoring these leaks. They will reopen these valves before docking procedures begin.
As previously stated, the crew is in their sleep period. We are looking for a crew wake to happen around 3:30 a.m. Central Time. That's 4:30 Eastern Time. So about 55 more minutes until the crew is awake. Once the crew is awake, they'll give an update to what they're doing and seeing uh, inside the Starliner. Before crew wake, in just about 10 minutes, we have heard the flight control team here in the White Flight Control Room say that we will be going over a maintenance burn, not a scheduled burn, but just something to get us in the right configuration or stay in the right configuration and continue towards that chase to the International Space Station. you're just joining us, this is live mission commentary from the White Flight Control Room for NASA's Boeing crew flight tests. NASA astronauts Butch Wilmore and Sonny Williams launched from the Cape at 10:52 a.m. Eastern Time, and is now 16 hours and 50 minutes into their flight. Boeing Starliner is chasing down the International Space Station. Currently, the station and the Starliner are currently 263 statute miles above Baikonur in Kazakhstan. Starliner just under 2,000 miles away from the International Space Station. In just about 5 minutes, we are looking for a maintenance burn to keep the Boeing Starliner in its right configuration. Next on the list for milestones for today will be the crew wake time. We're just about 45 minutes away from the crew waking up. Upon wake up, we will hear a status report from the crew.
So when crew wake up, that's considered the post-sleep period of a mission. And before they have a meeting with status reports for the day, they go into the post-sleep configuration, where they take off covers from the cameras inside the vehicle, take down window shades that provided light sealing for them to get appropriate amount of rest. If they need to do LiO changeouts or lithium hydroxide changeouts, they take care of that. They make sure that their tablets are fully charged and prepared for them for the day. Stow sleeping bags, any other kind of housekeeping items, and they have about an hour to do that before the status briefing for the morning.
After the status briefing, the next big milestone for the crew will be their second status update. That'll be closer to the time of docking. We are expecting docking to be at 12:15 p.m. Eastern Time. After that status report, we will be looking for an NPHCI burn, and that's a planar change burn. Again, reorienting Starliner's spacecraft to be more aligned with the International Space Station as we begin rendezvous and docking procedures. If you're just joining us, we're live in the White Flight Control Room at NASA's Johnson Space Center. I'm NASA Shaniqua Vereen, and I'm joined by Boeing's
Dee Dobson.
Hi, Dee. We will be with you for the next few hours to bring you live coverage of NASA's Boeing crew flight test. NASA astronauts Butch Wilmore and Sonny Williams launched aboard a United Launch Alliance Atlas V rocket from the Space
Launch Complex 41.
Space Launch Complex 41, Cape Canaveral, in Florida at 10:52 a.m. Eastern Time. The duo is now about 17 hours into about a 24-hour flight to the International Space Station. We're going to take a look at the launch day highlights to see just how their day went.
Starliner Houston on 1.
Go on 1.
Butch, sorry for the enabled caution. We are reconfiguring the prop system. No action for you.
Yep, copy, no action. I pulled up into you. We see it. Can you tell me how much longer it is before it's wake-up time?
30 more minutes till wake up.
Okay, over the night, I mean, it got pretty dang cold in here. I did turn the temperature up. I'm at the 1 o'clock position. I'd like to go higher. What thinkest thou?
Checking. But you are free to go higher, just do not exceed the 3 o'clock position.
Okay, I'm going to 3 o'clock right now.
Copy. Starliner, no action on the LCL temp controller fault.
No action.
If you're just joining us, we're live in the White Flight Control Room at NASA's Johnson Space Center. We are doing live mission coverage of the Starliner mission. That's NASA's Boeing crew flight test to the International Space Station. Launching Wednesday, June 5th from Pad 41 at the Kennedy Space Center in Florida at 10:52 a.m. Eastern Time, the inaugural crewed flight of the NASA's Boeing CST-100 Starliner is a critical mission demonstration for the aerospace company, which hopes to join as one of two companies making routine trips to orbit on NASA's behalf. The mission is the first crewed orbital test flight for Boeing following two previous demonstrations that were conducted with no astronauts on board. During the flight day highlights, we did hear from the commander of the CST-100 Starliner, Butch Wilmore. Butch called down to the Capcom on Rob Hayhurst, telling him a little bit early, because crew wake up is expected in just about a minute. About 25 minutes ago, Butch called down, and he was clearly awake. He mentioned that during their sleep period, it did get a little chilly inside the cabin. They were given the okay to make it comfortable inside the cabin for themselves, and so we're now gonna wait for official wake up to hear from the crew, and the status of Starliner. You'll hear some updates just here shortly. During the crew sleep period, we did have teams in Mission Control Houston, along with the Boeing Mission Control Room, find 3 helium leaks on Starliner. One of these leaks were previously discussed before the flight, along with a management plan. The other 2 leaks were new since the spacecraft arrived on orbit. The team here in Mission Control Houston is now making plans and have begun doing cycles of the A and B manifolds, the valves on those manifolds, opening and closing to increase the pressure. We'll hear the Capcom relay these messages to the crew here shortly.
Good morning, Houston. What a great way to be awakened with one of your own singing one of his own. And big thanks to Mike Fitzpatrick. That was fantastic.
And good morning to you, Butch and Sunny. Great to be talking to you on this day. Hey, we do have one item for you. Normally tell you this on the morning DPC, but if you get ambitious and start your post-sleep activities early and you get to your lithium hydroxide change out, Q-Card has you change the port Lyocan, but change the starboard instead since it is easier to get to. And give us a serial number when you're done.
Okay, we'll do the starboard Lyocan with the serial number call down. You bet.
All right, we'll talk to you in 50 minutes.
Outstanding. Actually, we're kind of curious where we stand as far as our leaks, and if we could get a summary on that, that'd be wonderful.
Copy, stand by. And Butch, sorry for the delay. Regarding the leaks we spoke of last night, the big picture is the current leak rates are, we are going to be able to support a rendezvous today with that. Big picture, what we're doing right now is we're getting the manifold pressures up to recover the jets, and Prop is working on that at this time.
All right, fantastic. Good words. Thank you. Okay, Houston, we're in 10.201. We're powering up DMC-1.
Houston copies. Starliner, when you're done with bringing up the FMC, when you bring up the DMCs, I have some words for you for the ERS manifold pressure.
Yep, I've got DMC2 was up, so we've got it. So go ahead.
Okay, we're getting close to our ERS manifold pressure pressure of 170, so we need you to do the burp. But prior to that, we want to do a little troubleshooting. If you could go to Eclipse ARS PCS on tab 1, take the ERS tank ISO 1 to close.
Okay, ERS tank ISO 1's coming close, and then we'll burp the BPMC.
Good read. Butch, thanks for those actions. We see the ERS system in a good config.
Good thing. Okay, I'm up to step 5 of 10.201, display system activation.
Copy, step 5.
Actually, I didn't do it via the panel switch, so I'm on step 6.
Step 6.
you're just joining us, the crew is now awake as of 3:32 a.m. Central Time, 4:32 a.m. Eastern Time. The crew wake-up song was by Houston's own Michael Fitzpatrick. He sung by himself, and it was called "Spread Out Your Wings." Mike Fitzpatrick is an environmental control engineer here that works for the flight control team. So that is an honor, and I'm sure the crew enjoyed that little bit of home waking up in space. After crew wake up, we did have some words from the Capcom Rob Hayhurst going out to the crew about the 3 leaks we mentioned earlier. As the crew was sleeping, they did have 2 new leaks appear for the manifold valves. Teams here in Houston, Mission Control Houston, have been working to get the pressure back up for flight readiness. The team here began cycling the A and B valve. The 2 manifolds that were down, they were initially closed, and they began to open them one at a time, increasing pressure over time, and have seen a rise in the pressure, returning to above the flight rule.
So we're about 24 minutes into the crew wake up period, and they have about an hour set aside for what's called the post-sleep configuration procedure. It's just general things that you do when you wake up in the morning, except in space. You adjust your lighting, you make sure your window shades are open so you can see the bright shining sunshine of day. For space, they make sure that the camera covers are stowed so we can get a look of what's happening inside the cabin. They install a couple of switch guards, and then they do a lithium hydroxide canister change out if necessary. That cleans their cabin breathing air. They make sure their computers are able to be charged, or rather tablets. We use tablets. General housekeeping, making sure their sleeping bags are put away and the air temperature is comfortable for them.
step 7, and looks like I'm complete with 10.201, and you've got post DMC activation cleanup.
We copy all.
All right, Houston, with a tab 17 on the CDH sum, we're ready to enable DMC1 fitter.
Copy checking. Butch, we are ready for that.
Okay, we sent the command. We're still standing by. I'm not sure if it's supposed to give me an indication now, if it takes a while, but so far it hasn't.
Copy. It is in a good config, Butch.
Outstanding.
I'm inside the White Flight Control Room here at the Johnson Space Center. I'm NASA Shaniqua Marine, and I'm joined by Boeing Systems Engineer Technician Dee Dobson. We are with you for the next few hours to bring you live coverage of NASA's Boeing crew flight tests. NASA astronauts Butch Wilmore and Sonny Williams had a successful liftoff aboard Boeing Starliner spacecraft on United Launch Alliance Atlas V rocket from the Space Launch Complex 41 at Cape Canaveral in Florida at 10:52 a.m. Eastern Time. The duo is now 18 hours into about a 24-hour flight to chase down the International Space Station. Some milestones that's covered thus far this morning. The liftoff, we then had orbital insertion, and we had a couple of burns to help orient Starliner. Since then, we have now had the crew wake up around an hour ago, a little early, scheduled for 3:30. We had the crew wake up time, and we now have the crew running through their post-sleep configuration procedures. About halfway through those procedures, after the crew wake-up procedures, post-sleep configuration procedures, the crew will have a private conference with the teams here at Mission Control. As the crew slept, we did have two new leaks on the Starliner. One leak we found during the flight before launch, and it was discussed and had a management plan. The other two were new since the spacecraft arrived on orbit. The team here in Houston is now working with the prop flight controllers to cycle through the A and B valves on the manifolds, which have been temporarily closed and opened again to raise the pressure slowly. The cycling of these valves is working, and the team is continuing towards docking. Again, we are looking to dock at 12:15 p.m. Central Time, Eastern Time.
One other bit of fun information for you this morning. As the crew were getting their rest overnight, if you pardon that interruption there. We had some things to listen to. So to get back to it, as the crew were resting in their period overnight, so was our vehicle. It was positioned in a manner so the tail was facing the sun, or rather our solar arrays on the bottom of the service module were facing the sun. As well, the vehicle was in a low power mode, so you could put together that the vehicle was resting right alongside the crew. Both were recharging at the same time. back in mission control this morning. Crew are still making their way through the post-sleep configuration procedure. But to recap what the team went through yesterday, before they went to sleep, they tested out a unique capability of Starliner on orbit, our manual piloting. Although the spacecraft is autonomous, the crew also have the ability to use a hand controller to point and aim the spacecraft, and they did that during about 2 hours of free flight demonstrations. Butch reported back that manual maneuvering was precise. Keep going. Even more so than when they tested it in the simulator. He said they could stop exactly on the number they wanted to stop on. He called the precision amazing. During a far-field demo, they pointed Starliner's nose toward the Earth so that its communications antenna on the back of the service module was pointed at TDRS satellites. Then they moved Starliner so its solar arrays pointed at the sun to prove that they could charge the internal batteries if ever needed in the future. Next, they swung Starliner around and pointed the nose away from the Earth to look at the stars. This was to in space in case all 3 flight computers were to ever go out or be turned off at the same time. Then, they manually sped up Starliner and slowed it back down, which slightly raised and then lowered the orbit. This was to show that the crew could manually break away from the space station break away from space station orbit during rendezvous if necessary. Finally, the crew manually pointed Starliner in the orientation needed for entry into the Earth's atmosphere, just in case they have to do that manually. During that maneuver, they again pointed the solar rays at the sun to try a different method of confirming they can manually charge the batteries. There is more manual piloting to come later today when they start the process of rendezvous with the space station, but for now, you can listen to the crew's own comments of how yesterday's activities went. Listen to this.
Right, Houston, I don't know if you heard me earlier. The new layout cartridges were serial number 0037 and 0038, and the ones we removed were 12 and 20, 12 and 20.
Copy all, Butch, and we got an LOS coming up in about a minute.
If you're just joining us, you're live inside the White Flight Control Room or the Starliner Mission Control Room at the Johnson Space Center in Houston, Texas. We're bringing you live mission commentary for NASA's Boeing crew flight test. We are 18 and a half hours into flight. We are looking for the crew to dock to the International Space Station around 12:15 p.m. later today.
Have you loud and clear, Butch?
Okay. I don't know if you heard my earlier call. Maybe I called one of the silhouettes. We're ready to take cabin fan alpha to off after powering or setting the speeds on A and C to 5.
And we are go with that, Butch.
And that was a call down from Commander Butch Wilmore inside Starliner. The crew is currently in their post-sleep configuration procedures. After being awakened at 3:32, the crew wake-up music was by Houston's own Mike Fitzpatrick.
All right, Butch, we see the cabin fan in a good config, and we are ready to start the morning DPC when you are.
Stand by.
And that was Capcom Rob Hayhurst talking to Commander Butch Wilmore inside the Starliner. They will begin a private conference going over the statuses of Starliner with the crew. Again,
Are you somewhere ready?
All right, first, we are really looking forward to a great day and a great rendezvous. I have 7 items for you. First, we'll go back to yesterday. You had your Flight Day 1 questionnaire that James Reel went through with you. He ran out of time, and there was one last question he needed to get an answer from you. And that is, using the Bedford workload rating, could you give us a rating on your activities for yesterday? That is including systems, vehicle interfaces, crew displays, and monitoring.
Stand by.
And Butch, that'll be question 28 from yesterday's questionnaire.
Okay. Sonny and I have conferred, and we both think that it was a 4. Insufficient spare capacity for easy attention to additional tasks.
All right.
We were fairly busy.
Copy that. We will pass that on. All right, going to the next one. There was talk of ISS needing to do a PDAM, but that PC went green and the PDAM was canceled, so you have no timeline tool updates for today.
No timeline tool update, great.
And also letting you know that a number of inhibits for the far field checkout are no longer required, so if you happen to need to go into sequence 34 and you have to bring up a computer, the following inhibits are not required, and that's 34.3 through 8 and 34.11 through 14.
Okay, inhibits not required, 34.3 through 8, 34.11 through 14.
Good read. And Sunny, just a friendly reminder, you'll be performing your grab sample container sampling at 11:20 prior to stepping into your rendezvous monitoring activity. For TDRA show updates, big picture, post-docking, we have solid comm on space-to-space, but much of the TDRA's direct for CST has been impacted, some good and some bad.
Okay, we copy.
And we wanted to get a read from you on the state of charge of the batteries of the two tablets.
Okay, one's on the charger. The one we're using right now is at 5757.
Okay.
Sunny's checking the other one. Stand by.
And if you could give us serial numbers with each of those readouts, that would help too.
Yeah, the one I just gave you at 57 is number 9.
Number 9 for 57.
And 12 is at 100%.
12 at 100%. Copy. And the last item for OFM inhibits are in place for early power-up. And once the morning DPC is complete, you are a go to press into rendezvous monitor step 5.
Okay, OFM inhibits are set, and we're jumping into step 5 of the rendezvous monitor.
That is a good read. Do you guys have any questions or comments for us?
Stand by 1 second. Yeah, I think part of what that Bedford workload of 4 drove us to that was we had some stowage issues. Some things were hard to find and were not configured as we expected. And so that set us back just a little, and I mean, we caught up and everything was fine, but it made for a long process after we got to Nico.
All right, that is great feedback. Thank you for that. Appreciate it. And with that, Butch, Sunny, I think we can call the morning DPC complete. Looking forward to a great day.
Okay, Rob Jack, and it's great to hear your voice. Great to be talking to the team this morning. We're looking forward to the rendezvous.
And great to hear your voice too as well, Sunny. Looking forward to a great day.
You just heard NASA astronauts Butch Wilmore and Sunny Williams during their morning conference with the flight control team here in Houston. Some of the things they went over was some of the statuses as the crew slept, as well as how charging of their tablets are going on board, as well as the next steps after the conference. Next steps is to go into the rendezvous monitoring for step 5. That step 5 is going to be early power up for their rendezvous monitoring procedures. Again, next up for the crew, the crew will be looking to do another state update around 6:51 or 7:51 Eastern Time. They will be looking for their NHPC-1 burn around 8:20.
All right, Houston, we have reviewed the notes on step 5 of rendezvous monitoring, and we're ready to start if you are.
Checking. All right, Butch, we are ready. You can start at the point for SMC activation.
Okay, so we're going to bypass the CDH sum and the sequence OFM steps, and we're going to go to the next section, the next page, which is power on SMC1. Is that right?
Yep, that is affirmative, Butch. And also, you can expect to receive some caution and warning messages associated as you're bringing up this SMC. No action will be needed when this occurs. Ground will re-inhibit the alarms that come up from the ground.
Copy all.
And you just heard a call from Commander Butch Wilmore inside the Starliner, talking to the Capcom here in Houston Mission Control for Starliner. They were discussing the next steps for the crew inside. They are looking to power up the SMC-1 or the Systems Management Computer. The crew will be looking to reboot that computer system. today's flight. Boeing Starliner is about 1,246 miles away from the International Space Station. The International Space Station and the Starliner are both about 258 statute miles above the Earth currently off the coast of Papua New Guinea. Again, we are looking for Starliner to dock to the International Space Station at 12:15 p.m. Eastern Time.
And Starliner, that was the expected cabin fan Delta P low, no action.
Copy.
Crew aboard the Starliner as well as the International Space Station are both awake at this time in their post-sleep procedures. And as you just heard for the Starliner crew, they are doing the post-sleep configurations. They're currently doing some cabin fan fault detections, cycling through some fan updates, and they previously did a LIO or a CO2 scrubber change out. So they're powering through that. They have about an hour of these procedures. They are about 45 minutes into those procedures now. Again, crew aboard the International Space Station is in their post-sleep, just waking up to be in the same ops and time as the crew aboard the Boeing Starliner. We will have NASA astronaut Matthew Dominic as lead, monitoring the docking of the Starliner later today. Again, we are looking for docking to be at 12:15 p.m. Eastern Time. Along with Matthew Dominic, we also have NASA astronauts Michael Baird and Jeanette Epps, as well as Tracy Dyson. Along with those are Roscosmos cosmonauts Alexander Gorankin, Oleg Kononenko, and Nikolai Chub.
All right, Houston, we're powering up FMC 1 and 2.
All right, Butch, before you do that, in the off-nominal block on step 5 on the second page, we did see the time miscompare, so we would like for you to execute the tab 24 as called out in the off-nominal column.
Yes, you're right. We do have that. Thanks.
Again, that is Capcom Rob Hayhurst speaking to Commander Butch Wilmore aboard the Boeing Starliner, and he's running him through the procedures to reboot that systems management computer.
Okay, Houston, that's complete. Here comes FMC 1 and 2.
We're watching.
just joining us, we're live inside the White Flight Control Room, or as it's known today, the Boeing Mission Control Room here at the Johnson Space Center. I'm NASA Shaniqua Vereen, and I'm joined by Boeing System Engineer Dee Dobson. We will be with you for a little while longer as we cover live mission coverage for NASA's Boeing crew flight tests. NASA astronauts Butch Wilmore and Sonny Williams had a successful liftoff aboard Boeing Starliner spacecraft on a United Launch Alliance Atlas V rocket from Space Launch Complex 41 at Cape Canaveral in Florida at 10:52 a.m. Eastern Time. The duo is now 19 hours into about a 24-hour flight to chase down the International Space Station.
Starliner, we are ready for Mustang camera activation when you are ready for us to turn it on.
You're free. Let's do it.
And work. cabin temp.
We were just talking about how nice it was now.
Well, hate to ruin that for you, but we are seeing SM electronics warming up. We're wondering if you can stand it to go to the 2 o'clock position. We expect the cabin temp will be about 70 degrees F at that position.
Okay, it's at 2 o'clock.
Thank you.
And that was Capcom 2.
All right, Houston, we're ready to power on Siggy's 1 and 2.
We're ready for that.
Houston, we never did get standby on Siggy 1 after we powered it on.
Checking. And Butch, we are seeing it in standby. We believe that it may be just the FMC source for DMC1. You would need FMC1 as a source for DMC1 to be able to see the standby.
Okay, got it. That makes sense.
You're good to continue.
All right, we're going to inhibit 2.99 on OFM.
And Butch, we need Siggy 2 on before you do that.
Oh, yeah, sorry about that. Good call. I'm glad I called you.
Anytime.
All right, Houston, once again, we did not see standby mode for Siggy 2.
Yeah, same issue as before, Butch. We are seeing it on the ground. You're good to continue.
That's what we figured. Okay, now we'll inhibit 2. It says 2.99, but I think it means 2.099, which is the next in the sequence.
Affirmative. 2.099.
Get lab.
And Butch, those warnings were expected.
Expected.
And the calls you're hearing from the crew down to the flight control team here is you keep hearing Siggy. Siggy is the space integration GPS system. They are cycling through Siggy 1 and 2.
All right, Houston, FMC 1 and 2 are showing orbit. SIGI 1 and 2 are not showing nav. Oh, they just did. Never mind. And we're standing by to see when they go to enable.
Copy all. Starliner, be advised our comm bore site is getting a little bit high, but we expect to have a good return link.
Copy. Houston, we remember in a sim once, we had to enable these SIGIs manually. It didn't just happen. I'm curious, since it's been 5 minutes, if that's the case now.
Checking.
Never mind. There they went.
Glad we could help.
Y'all are wonderful.
And that was words from Commander Butch Wilmore aboard the Starliner spacecraft, confirming a good configuration for the SIGI 1 and 2 after a power cycle. SIGI, again, is that Space Integration GPS system for navigation aboard the Starliner spacecraft.
All right, Houston, we're picking up. We will be picking up when we get there in step 7. So I think we're on hold till then.
Butch, we concur.
If you're just joining us, we're doing live coverage at NASA's Johnson Space Center of NASA's Boeing crew flight tests. NASA astronauts Butch Wilmore and Sonny Williams had a successful liftoff aboard Boeing Starliner spacecraft on a United Launch Alliance Atlas V rocket from Space Launch Complex 41 at Cape Canaveral in Florida at 10:52 a.m. Eastern Time. The duo is now 19 hours and 32 minutes into about a 24-hour flight to chase down the International Space Station. The inaugural crewed flight of NASA's Boeing CST-100 Starliner is a critical demonstration for the aerospace company, which hopes to join as one of two companies making routine trips to orbit on NASA's behalf. The mission is the first crewed orbital test flight for Boeing following two previous demonstrations that were conducted with no astronauts on board. After reaching orbit this morning, the crew went to sleep, but before going to sleep, they did perform some demos aboard the Starliner spacecraft, the main one being the manual piloting of the spacecraft. After said demos, the crew were in a sleep period for 8 to 9 hours. Crew was awakened by music of their choice at 3:32 a.m. Central Time. The crew had a special wake-up song. It was Houston's own Mike Fitzpatrick. Mike Fitzpatrick is an EECOM, or an environmental control flight controller here in Houston, and he sung a song entitled Spread Your Wings. After going into wake up, they went into their post-sleep configuration procedures. This included turning on some computers and swapping out some LiO canisters, and now they are rebooting some things on board Starliner, such as tablets and monitors, as well as a couple laptops on board. The crew also has been mentioning SIGI 1 and 2. SIGI is the Space Integration GPS systems. They have power cycled those, and they are now back online. During the sleep period, there were some leaks that were presented. These leaks were in manifolds, 2 in the port doghouse and 1 on the zenith manifold. They have now been all reopened but 1, and we will reopen that one before the NHPC-1 burn. Again, the NHPC-1 burn is expected around 7:51 a.m. Central Time or 8:51 a.m. Eastern Time. That NHPC-1 burn is going to be that planar change burn. Again, that's realigning Starliner to better dock and rendezvous with the International Space Station. 19 hours and 42 minutes into today's flight. Starliner is just under 1,000 miles, about 934 miles away from the International Space Station. The International Space Station is flying 259 statute miles right off the coast of Morocco. Again, 259 statute miles off the coast of Morocco, Africa. If you're just joining us, we're live in the White Flight Control Room, or the Boeing Starliner Mission Control Room, today in Houston, Texas. I am NASA Shaniqua, and I am joined by Boeing Systems Engineer, Aerospace Engineer, Jim May. We will be with you for the next few hours to bring you live coverage of NASA's Boeing crew flight tests. NASA astronauts Butch Wilmore and Sonny Williams had a successful liftoff aboard Boeing Starliner spacecraft on a United Launch Alliance Atlas V rocket from Space Launch Complex 41 at Cape Canaveral in Florida at 10:52 a.m. Eastern Time. Now, just about almost 20 hours into a 24-hour flight to chase down the International Space Station, the duo is now in a post-sleep configuration, and they are looking at procedures to press forward for rendezvous and docking. Again, we are looking for docking to occur around 12:15 p.m. Eastern Time.
And while the crew is getting through this post-sleep phase, they have a few things to look forward to. We're going to be looking for the crew to do their morning, crew time morning, private audio conference. Once they get done with that, they're going to start. And then the crew are going to start their rendezvous and monitoring phase that'll last until docking. Here in just over 2 hours, the next major maneuver we're going to see for Starliner is called the NHPC-1 burn. That's height adjust plane change 1 maneuver. That's going to bring Starliner's altitude up to, but not quite all the way into the International Space Station approach ellipsoid. That's the first major maneuver to get us close to proximity operations, which is where the ISS and Starliner crews will begin their joint operations. Once Starliner reaches the ISS approach ellipsoid, there'll be a handful of other maneuvers. We'll do an inbound fly-around maneuver.
Starliner, for the enabled PPS messages, we are taking a look at it, but no action for now.
No action for now.
About 3 minutes shy of a 20-hour MET, the crew aboard Starliner has now been awake almost 3 hours. Again, being awakened around the 3 a.m. time frame, the crew, after being awakened, was told about a couple things that happened during their sleep period. During the sleep period, the Starliner experienced a few more leaks. One leak which we knew about upon launch and we had a plan for, and the other 2 leaks occurred during the orbit time frame. The leaks were in the manifolds, 2 in the port doghouse and 1 on the zenith manifold. Since crew awake, we have been able to power cycle and actually do on and off for an A-B cycles for the manifold 1 and 2, and All but one manifold is now back online, and we will reopen that one before the NHPC1 burn. Again, we are looking for that burn to occur around 7:51 a.m. Central Time, 8:51 a.m. Eastern Time. Again, that is a planar change burn, basically correcting the attitude and alignment of the Starliner to prepare it for rendezvous and docking operations. They have been in their post-sleep configuration procedures. In these procedures, they have rebooted some computers. They've swapped out a LiO canister for CO2 scrubbing. Some. They've done a morning conference with the crew here in Mission Control Houston. Um, we've also done some power cycling on the systems management computers 1 and 2. And we also heard a call down that the Mustang camera was ready for activation. Again, next major milestone, we're just under 2 hours for that NHPC1 burn.
Starliner Houston, air to ground 2 is configured for your PMC, and we're wondering. Starliner Houston, air to ground 2 is configured for your PMC, and we'd like to know if you're able to complete your recorded PAO event.
Okay, ready for the PMC, and we really had nothing to say for the recorded PAO event, so we did not do that. But we can throw something together here. We got time.
Copy.
And you just heard a call from the Capcom here in the White Flight Control Room to the crew aboard the Starliner. They are going into a PMC, or a private medical conference. These are standard and a part of the timeline to go over how the crew is feeling as their time in flight continues. After their private medical conference, the crew is going to participate in a public affairs event, recording something for later for those on the ground. If you're just joining us, you're looking live into the White Flight Control Room at NASA's Houston Johnson Space Center. You're seeing a lot of comings and goings as Orbit 1 prepares to go home and Orbit 2 prepares to take the reins. They're doing a direct handover right now between them and their counterparts.
And Houston Starliner, we're back with you on air to ground 1.
All right, copy, Sunny. We will get air to ground 2 normalized. Starliner, that was a transient caution as the Vistas come up.
Roger that.
and you heard a call to the crew from the Capcom here in the White Flight Control Room, where they acknowledged that the Vistas were coming online. Vistas are 6 cameras aboard the um, outside of the Starliner vehicle. That's 2 LiDAR units, 2 infrared cameras, and 2 standard cameras that make up the visual base electrode tracking assembly. And this is used for star tracking and navigation um, using image recognition in a 3D version, being able to see and know where the International Space Station is upon docking, rendezvous and docking.
Starliner on 1.
Go ahead, Butch.
Sorry, Houston, I didn't hear you. I understand you did respond. So Sonny and I are going to go ahead and do a Mustang right quick. And since it's still kind of chilly in here, I'm going to go ahead and suit up for rendezvous, my parcel suit donning. And we're just going to do that. She's going to talk through it as I do it. But like last night, we'll have to be talking on Air to Ground 1. I think y'all recorded and then they sync it together. So if you're ready for it, we're ready for it.
Copy, standby. All right, Butch, prior to doing that recorded TO event, we need you to step into steps 8 and 10 of rendezvous monitoring to be ready for the night pass.
Okay, we'll put that in work. Okay, we're stepping into step 8 right now.
Copy.
And Houston, step 9 says after maneuver NAVCAL 1, but you say we can go ahead and do step 10, is that right?
Yeah, you can skip to step 10. We're going to hold step 9 until we get done with the maneuver to the NAVCAL 1.
Yeah, so it's okay, well, we'll go ahead and do 10.801, Sig Energy, here we go. All right, Houston, we're going to be inhibiting Siggy's 1 and 2. Procedure.
Copy, standby. All right, Butch, yeah, we are ready for you to inhibit Siggy's 1 and 2.
Here we go.
Starliner, there's transit cautions. We're expecting no action.
Copy.
If you're just joining us, we're live in the White Flight Control Room here in Mission Control, Houston. I am NASA Shaniqua Vereen, and I am joined by Boeing engineer Jim May.
We're at 1.5. We're re-enabling Siggy's 1 and 2.
Copy, and we're ready.
Sonny's going to do the grab sample container, and then we'll knock off the PAO Mustang thing if you're ready.
Copy.
And you heard a call from Commander Butch Wilmore aboard the Starliner spacecraft. They are going into the PAO Mustang event. Again, that is going to be an audio-only status update from the crew aboard the Starliner on how things have gone thus far in their journey towards the International Space Station. Again, this is 20 hours and 36 minutes into about a 24-hour rendezvous with the International Space Station. Again, we're looking for docking to happen around 12:15 p.m. Eastern Time.
morning, everybody. Here we are in the capsule, Calypso, in our spacecraft, and it is rendezvous morning. We've gotten up, we've got ready to go. Woke up from our slumber last night, sleeping in here, and we're just ready to go. So part of getting ready to go is the rendezvous monitor checklist. We're doing that, and get ready for the really critical parts. When we put these two spacecraft together in space, in case anything happens, we need to be ready. So Butch is getting in his spacesuit, as you can see from the camera. Now, it's not like a whole, suit room, so we got to be careful and watch out for all the stuff around us. We have a centerline camera, like right in front of Butch's face right now, and that will actually guide us in for the rendezvous. Or you can see he's putting his whole suit on, halfway on. Now it's going to be the fun part. You're going to probably see his butt in this part of the picture as he turns around to get ready to put his head in. All critical stuff like jewelry, watches, and stuff like that you take off before you get into your space. Okay, so to get on, he's got his legs in already. Now he's putting his arms in. As you can probably see, it's a little bit of a big blue stuff in front of the camera right now. He's got his arms in. He's got his bottom up to the mid-thigh, and you have to be in this type of orientation to be able to squish your head down and then pop it on through. And that's what he's doing right now. And out he comes. Butch has donned his suit. Now he's in it, and you just got to zip it up on the back. Yep, and I'm going to help him real quick and get all the wrinkles out so he doesn't have a little bit of feel funny sitting. There you go. Look at that. Instant spaceman. He's in his suit, ready to rock. He's got his flashlight on. He's checking all his tools and equipment and stuff like that. He will be ready to go. So he's going to slide now. You can probably see him. He's going to, first and foremost, he has to put his boots on. And in reality, we're up in space. We don't actually have to have our boots on, but they're nice protective covering for the bottom of the spacesuit. Remember, it's a pressure suit. If anything happens, we want to be able to use that to protect us. So it's nice to put these boots on just to make sure the feet don't get caught on any of the little edges that are in here and create any problems. And the boots have, they're actually running shoes, but integrated into boots, and they have two zippers, one for the inner layer and one just for the outer protective layer. So there's a couple layers here that we just make sure are all good to go. We don't get anything stuck or lost in there. Close it all up. You can see on his pants there's a couple little pockets also, one on each thigh and then one on each shin and then one on his thigh, and those have all of our survival equipment. So in case we ever had to bail out from the spacecraft, landing back at home, in the ocean, for example, there's equipment in there to help us survive, extra water, extra food, other survival equipment. Yeah, a whole lot different than being on the ground where we had to sort of shove ourselves from right to left to get into seats. Here we can just slide right under the display panel and jump into our seats, as you can see he's doing right now. And from the other Mustang camera, you probably got a nice view. mentioned earlier the centerline camera, which we'll be using for rendezvous. As you can see, the wire is coming up to Butch's left side. That will be plugged into a tablet, and you will be able to not only see the displays and the camera views through the displays, but also the centerline camera view on a tablet. And so we have an entirely separate system as a backup system. In case anything happened to the primary system, we could actually fly in manually ourselves using our centerline camera. You can see in the other Mustang camera now, Butch is strapping in his spacesuit, looking like a spaceman. And in reality, we don't really have to strap in. We can sort of hold ourselves with our toes or our knees, like we've done before. But if he has to take over manually, or just to be able to pay attention and not to think about stuff, we just sort of strapped ourselves in. That way, you're just not worried about floating around. And with all that action, he's hungry, so he's gonna munch on some macadamia nuts. But you want to say hi?
Well, that's how you get in a spacesuit in space. It's not easy. Actually, it's not near as hard as on Earth. But it takes a little bit of doing, but we got her done.
All right, Houston, we will be done with our PAO, and thanks for paying attention and playing along with us, and we're ready for rendezvous.
All right, Sonny. It sounded great. We can't wait to see the video that goes with it.
And that was the conclusion of that Mustang PAO event.
Houston, officially the CDR suit is partially donned.
Copy. CDR partially done.
And again, that was the conclusion of the Mustang PAO event. We had a mini tour, a look inside the Starliner. Not on camera just yet, but we'll have that video as soon as they dock to the International Space Station. But we heard pilot Sonny Williams go over suit donning and the importance of that, as well as looking around inside the Starliner a little bit. Again, we'll have that video down as we dock to the International Space Station. We're looking for docking to occur at 12:15 p.m. Eastern Time.
You can tell Rendezvous that we are getting our game faces on early.
We will let him know. He's doing handover right now.
If you're just joining us, we are live in the White Flight Control Room, currently being used as the Boeing Mission Control Room today at the Johnson Space Center. We had a successful launch of the NASA Boeing CST Starliner at 10:52 a.m. Eastern Time. NASA astronauts Butch Wilmore and Sonny Williams lifted off aboard the Starliner spacecraft aboard the United Launch Alliance Atlas V rocket from Space Launch Complex 41 at Cape Canaveral in Florida. The duo is currently 20 hours and 49 minutes into about a 25-hour flight to chase down the International Space Station. After a successful launch into orbit, the Starliner completed some needed necessary burns to get its orientation and alignment correct for rendezvous and docking. Again, along the way, the crew has had some maintenance burns to correct that path. The crew went to sleep for about 8 to 9 hours, with the crew wake time around 3 a.m. this morning, Central Time. During that sleep period, Starliner did come up with a couple prop system issues, and they had a couple leaks in the 3 manifolds, 2 in the port doghouse and 1 on the zenith manifold. We have now reopened all but 1 manifold, and we will reopen that one before the NHPC 1 burn. Again, that is a planar change burn, correcting that alignment of the Starliner to help with rendezvous and docking procedures. We're looking for that burn to occur around 7:51 a.m. Central Time, 8:51 a.m. Eastern Time. Again, Starliner and ISS management teams met during the night and have pulled go for docking and rendezvous operations. And again, those leaks, 2 of 3 have been corrected, and we do not expect the leaks to impact docking. If you're just joining us, you see a busy white flight control room here at Johnson Space Center. White flight control room is going to be the Boeing Starliner mission control room. Currently, you see the Orbit 1 team ending their time as we see Orbit 2 coming in to start their shift. This will end my time with you guys this morning, but Leah Cheshire will be up next to continue coverage for the Boeing's crewed flight test in the white flight control room. She'll be joined in the Flight Control Room 1, or the ISS Flight Control Room, by Gary Jordan.
Starliner Houston, Air to Ground 1 for Sunny. Good morning.
Good morning, Neil. With ya?
Hey, we were looking for, if you still have them, the serial numbers and the sample locations of the GSC, since we don't get those in the, through IPV.
Oh, yeah. Okay, hold on 1 second.
Sure.
Just to share a little bit with you, Houston, just on these jet firings, it's like somebody's playing with the pipes in the basement. That's what it sounds like.
That sounds really cool. I wish I knew what a basement was, though, in Houston.
Yeah, Houstonians would not know basement, but us Tennesseans, we have them.
So is it like someone hitting them with a wrench or something? Or is it...
Yeah, somebody's working on like a heater system. If you ever saw A Christmas Story, but the dad goes downstairs and he's fighting with the pipes. You can hear him down there. Except for the cursing, it sounds just like that.
Roger that. Hey, thanks for sharing that.
And Neil, it's 1202, and I took it in the center of the cabin, like underneath the IVA hatch.
All right, copy. 1202 in the center of the cabin. Hey, Butch Neil, I got another sound question for you.
Go.
What about the OMACs? What do they sound like?
Trying to think of how to put it into words.
Well, we'll have another opportunity here in like...
Well, I can tell you what it feels like. I was gonna say I'll tell you what it feels like. You know how when you were a kid, your dad spanked you and it was pretty painful, but your mom did and it was not as painful, but you could still feel it. It's kind of like that.
Okay, copy that.
I probably got spanked more than most kids, so that's why I have that kind of feel for it.
Roger that.
one thing, just to kind of tie everyone in, to tie English and all in, while we got a minute, we'll call it the cone filter that's on the deck behind Sonny's head. That thing was full of just dust and little pieces of rubber gloves and whatnot. So we cleaned it up with some tape. It's all cleaned out now, but it was packed full.
All right, yeah, copy that.
Yeah, and just for, housekeeping, to let you know what our configuration is, I got rid of my foot pan, took that out, just gives us a lot of room to move around the post insertion bag, put it in that, under the starboard shelf, because there's plenty of room over there. Stowed our suits where the IDA hatch would be, was a great place to put them out of the way, and the big, structure frame, the big silver structure, allowed them to stay there without any problem. I slept back in there with those suits, and Butch slept in the seats. Just a little bit of a housekeeping.
Okay, yeah, copy all. Thanks for the information. And I trust it worked out well, huh?
Yeah, that all worked out well. We did not even put up the privacy curtain. We have enough space in here to maneuver around and stay out of each other's way, so it's nice to have that side hatch window to look out as well to, to see where the sun is and stuff like that, so we didn't want to block that off.
Okay, yeah, roger that. That makes sense.
One other thing I'm just noticing is on my pilot panel, comm pilot panel, I don't know when this happened actually, but it looks like some of the rubber that goes over those switches has sort of come off. I don't know if it was like that when I got in the spacecraft or not, but just the corners of some of the, the buttons, the raised part of the rubber, sort of seems to have come off, and that's probably some of the stuff that we found in the cone filter.
Okay, so the rubber actually physically came off the buttons and then migrated its way over to the filter? Just reading that one back.
Yeah, just little pieces and parts, not the whole thing, just like little corner pieces.
Okay, yeah, copy that.
And one thing we wish we could show you is the view. Wow.
Yeah, I bet you it is spectacular, and it's a long time coming for you guys.
Yeah, we need a better adjective than that. Spectacular doesn't even do it justice.
Copy that. Thanks for sharing that. That's good for everyone. Big time suggests glorious.
That's closer. Yeah, it's definitely something going on with the furnace in the basement. That's definitely we just had another one. So yeah, that's what it is.
Yeah, copy that. And did it disturb your sleep at all?
It was like white noise, man. It was great.
Roger that.
Good morning, everyone. We are live in the Boeing Starliner Flight Control Room here at Mission Control Houston at NASA's Johnson Space Center. I'm NASA's Leah Cheshire here to join you for the rendezvous and docking of the Starliner spacecraft on NASA's Boeing Crew Flight Test mission carrying astronauts Sunny Williams and Butch Wilmore to the International Space Station. The crew lifted off on time yesterday at 9:52 a.m. Central Time and are coming up towards the end of this leg of their journey, preparing to dock with the International Space Station at 11:15 a.m. Central Time, coming up in just over 4 hours. The crew woke up this morning at approximately 3 a.m. Central Time after a night of sleep and have been quite talkative as they prepare for the next phase of this mission.
Starliner Houston Air to Ground 1, the final target state update's complete.
Fantastic. .40 minutes to NHPC-1. Now we're back in the sim. At the start.
Roger.
Heading AFCAL 1.
Concur.
Hearing Butch Wilmore confirm that we're just under 40 minutes away from the NHPC-1 burn. NHPC-1 is the first of...
And it looks like, Houston, when you get that intense duty cycle, just jets firing continuously, it looks like it happens mostly when it's adjusting for roll.
Good info.
The NHPC-1 burn is the first of two height adjust plane change maneuvers. Majority of that maneuver is a height adjustment to raise Starliner's altitude to be closer to space station altitude, and then any small amount of plane change needed to help align their orbits. And following up from the helium leak that was noted during yesterday's portion of the flight, from now until during all of Starliner's rendezvous and proximity operations, we'll keep those propellant manifolds open, but they will stay open until docking. Starliner is currently maintaining plenty of helium reserves, and we expect over 90 hours of free flight propellant capability after undocking. Currently, the helium leak is not a safety issue for the crew, the vehicle, or the mission.
All right, Houston, step 9 of rendezvous monitoring looks good. We're holding step 11.
Yeah, we agree. And I got a couple of questions for you. Actually, it's a request for Sunny or you. Take pictures of the pilot panel for the audio, the rubber stuff flaking off, and then any temps though that you all have done. That'll be good for us to know as we continue to develop the spacecraft. And then from a temperature perspective, we noted that it's been running cooler in the cabin. For your experience, is that more from like the air vents? Is it from the structure, or is it like the whole thing is just cold?
Yeah, it's the whole thing's cold. If the air coming out is cool, you can't even kind of put yourself against the bulkhead. The bulkhead's cool. So yeah, it's just a chilly place.
All right, roger that. Thanks, Butch.
What temp are we running right now?
Just stand by. Hey, Butch, we're showing about 24.8 degrees C, which is like 77 degrees F. That's on our temperature sensors. Does that correlate to what you're experiencing?
No, it doesn't feel that warm. My fingers just now got thawed out by putting them on my forehead since I've been sitting here in the seat with the suit on. So now it feels chillier now.
Okay. And for the air coming out of the vents, we're looking at about 69 degrees Fahrenheit, and the air going in is about 72. So it's, I don't know, maybe 70 degrees on average.
Yeah, okay.
Now less than 4 hours to docking. The first attempt today coming at 11:15 a.m. Central Time. Starliner continues to chase down the International Space Station, which is currently flying at 17,000 miles per hour orbital velocity, about 263 statute miles above central Poland. And again, this is a view of the white flight control room here at Johnson Space Center. There are 3 main flight control rooms here, red, white, and blue. Today, the Starliner spacecraft is being commanded in the white flight control room, but we will start to hear more voices come into the mix as we enter integrated operations, which happens at the time of approach ellipsoid entry. This is when we bring in the teams from the International Space Station flight control room as the spacecraft will get closer to the orbiting laboratory. We use this approach ellipsoid as sort of an invisible boundary to monitor arriving and departing spacecraft, whether or not they are carrying crew or cargo. We expect approach ellipsoid entry to come around 9:38 a.m. Central Time.
Houston on Wattville 1 and Wattville 2. We're getting that striped return. That might be normal for this phase.
Yeah, copy that, Butch, and we expect that to clean up as we progress today, but of course we'll keep an eye on it.
Okay.
And Butch, while I've got you for prop, last night when I left, we had isolated effectively top 1 and port 1 helium manifolds and the associated jets. Overnight, I think Rob Jack told you that we reopened those manifolds. But overnight, people did some number crunching. We're going to go ahead and feed those leaks. They're small enough that we've got margin for today's opportunities and then the rest of the mission activities required. So you have all jets available.
Yep, we see that, and we do appreciate that information.
Yep. Also, regarding tablets, Richie was wondering if we should continue to remind you every time we see the current drop to, sort of tend the tablet charger, or if that's something you guys just wanted to deal with on your own today for the profile going uphill.
Yeah, we don't mind you reminding us, bring it.
Okay, copy that. All right, so we'll go ahead and take a reseat of the tablet charger. We're going to have to get that data down here, and I'll let you know. All right, Sonny. Hey, looks like the reseat got us up in the higher charge rate. And if able, can you go ahead and let us know which tablet's on a charger and battery charge, state of charge?
tablet 949, and it's sort of been stable. Overnight, we were able to get 100% on tablet 12, and so it's off, and we're just holding that to be the centerline camera.
All right, copy all. Thanks, Sonny. And Starliner just got into target track, and rendezvous reports were tracking the ISS with narrowfields.
Yep, we got a little blip. We're seeing it too.
And that comms between the ground and the astronauts aboard Starliner, letting them know that they are now starting to see the International Space Station, their destination today. Again, our docking window opens at 11:15 a.m. Central Time. They mentioned they have shifted into target track of the Vistas system. These are essentially the eyes of the spacecraft looking out for the International Space Station, and eventually, as we get closer, we'll hone in on the International Docking Adapter at the Node 2 forward port.
Flight controllers here in the Starliner White Flight Control Room are bringing up a view of the Vesta camera, the narrow field camera that Starliner is using to track ISS. Right now, ISS looks like a small dot on the horizon, but as we get closer, Starliner will be able to track more than just distance to ISS. It will also be able to do feature recognition of the outline shape of ISS to help better estimate Starliner's relative orientation to ISS as it gets closer to docking.
Starliner, be advised, we're going to have to do an S-band string swap to string 1 to do some file management on the SMCs. Just letting you know that that's going to happen, and I'll call you when it does. Also, Katie's advising that we go to 230 on the cabin temp dial to get the temperature up a little bit.
230 cabin temp valve, copy the SMC swap.
And Butch, it'll be a spacer ground swap, and I'll let you know when we get on the other string.
Okay, copy.
Coming up on the display, showing on the live feed now, you can see a small white dot with a red circle around it. That is the image that Vesta is taking, and the white dot there in the middle is Starliner seeing ISS off in the distance.
And with you on S-band string 1, also the LCL temperature controller fault, no action at this time. Katie's taking a look. We may have an action. Stand by.
Standing by.
And it's worth emphasizing that we still have good cooling.
And that was the voice of Capcom Neil Nagata speaking with the astronauts aboard Starliner. Capcom stands for Capsule Communicator. This is the single person in the flight control room that relays information to the astronauts, gathering all of that data from teams here on the ground. That way they have a single point of contact instead of several voices speaking to them. We're now about 13 minutes away from the NHPC-1 burn. This is a height adjust burn, bringing Starliner closer to the space station. We have several milestones that we're tracking this morning. We'll get into our integrated operations again when we come into the approach ellipsoid. That's a 4 kilometer by 2 kilometer by 2 kilometer invisible sphere around the International Space Station. Once the spacecraft has executed the approach corridor initiation burn, it will hold at about 260 meters away from the space station for another manual piloting demo. If you were watching yesterday evening, the crew conducted the first manual piloting demo, taking control of Starliner and testing how it would fly manually. Because the crew reported that that test went well, they are now able to do that same manual piloting in proximity operations today.
Starliner, for your LCL temp caution, what basically happened here is both one pump controller decided on one temperature set point, the other one decided on another, and so they diverged from each other. In order to try to fix this, what we would like you to do is to take the cabin temp controller all the way cold, all the way hot, and then back to 230. And you don't have to worry about doing it slowly. Faster is actually better for this to get the two set points to try to sync up.
Okay, you stopped talking like we had a handover or you were getting information.
Yeah, sorry, Butch, that was my fourth time this flight. I will get better. I went right into a handover. So essentially what happened was two controllers selected two different set points when we adjusted the cabin temperature. So to help fix this, we'll go full cold, full hot, and then back to 230. Don't worry about doing it slowly. Faster is actually better for this to try to get the pump controllers in sync.
Cold, hot, back to 230. Here we go. That's complete. No action, LCL2 pump
warning. It just went out of alarm as a transient as things were readjusted.
No action.
And caution's the same type as before, no action.
Copy.
And Butch, we're fitting to swap the string back to string 2. I'll let you know when we're there.
Coming up on just under 8 minutes to the NHPC-1 burn, Starliner is currently rotating to what's called thrust align mode. That is going to point Starliner in the direction it needs to perform the NHPC-1 burn.
Starliner, back with you on Space to Ground 2. S-band string 2. Good pre-NHPC-1 sensor pass. No action on that caution. It's related to the temperature switch.
Okay, we think you were coming up air to ground 1 there.
Yeah, I was coming up on air to ground 1. I was just telling you that we're on the Space to Ground 2 radios, S-band string 2.
Gotcha, thanks.
And Butch, I think you were talking back to me on the air to ground 2 loop.
Yes, I was, but I'm back.
Good to have you back. Starliner, you're a go for the NHPC-1 burn.
Go for NHPC-1.
just a few moments ago, you heard Commander Butch Wilmore and Capcom Neil DeGata confirming that Starliner is go for the NHPC-1 burn. That's coming up here in about 4 minutes.
Now less than 1 minute away from the NHPC-1 burn, this is a height adjust burn, bringing us closer to the International Space Station.
Looking at 25 seconds till the NHPC-1 burn. We're expecting that to be about a 9-second burn. And 5 seconds till the burn. And we're burning for Godomax.
Starliner, good burn.
Good burn. And that Ohms burns are more of a jar when it cuts off than when it begins.
Oh, copy that.
That's a fine way to start a rendezvous right there.
Make sure we're paying attention.
It sounds like Commander Butch Wilmore is happy with that first NHPC-1 burn. That is going to raise Starliner's altitude to about 409 kilometers. As you reach apogee, that part of Starliner's orbit, Starliner's going to come up just underneath the approach ellipsoid for station.
And that burn was conducted using some of the OMAC thrusters. As Jim mentioned, those are the orbital maneuvering and attitude control thrusters. Once we get closer to the International Space Station, we will opt for more burns using the RCS thrusters, or the reaction control system. These firings are for minor changes in orbit and help us to fine-tune our approach to the space station.
The next burn that we're expecting to see is the NHPC-2 burn. It's a small adjustment to the current trajectory that Starliner's on. That burn should be happening in just over 20 minutes from now.
Another thing of note for the burn, that Holmes burn, is the attitude deviations are more remarkable than the sim as well. We're up to plus or minus a full degree per second on the rates.
Okay, yeah, just read that back there a little. Sounds like it's a little sharper as we're in the burn.
Well, I don't know. The sim is tighter. This one is it wavers a little bit more. I mean, 1 degree a second is not a lot, but like I said, it's bouncing back and forth. So,
Okay, yeah, copy that. It's good to know.
Looking at the rate.
Teams across the hall in the International Space Station Flight Control Room will soon prepare for their poll to begin integrated operations. That's when Starliner will cross the approach ellipsoid and begin entering more of the orbit of the International Space Station, or I should say the atmosphere.
A little more information for the team while we're waiting. During launch yesterday, when we got to BECO and the Atlas cutoff, I don't know if you ever heard about the train wreck that they called it between when the Saturn V would launch and the first stage would power down, and then they would all fly forward in the seat, and then the second stage would light off, and they called that the train wreck. I don't know that it was maybe not train wreck, but it was significant, where we got flung forward at 0G, and then when the Centaur finally lit off, it was pretty cool.
Yeah, that's that sounds really really neat. It's kind of like the movies that I imagined when they were staging on those.
Yeah, exactly. And also, throughout the Centaur time period, it was pulsing about a half a hertz, about every 2 seconds. It was just a constant pulse, and it wasn't steady, just pulsing all the way. That was pretty neat too.
Good report. Thanks for sharing that, Butch.
I guess what made me think of that is that we didn't have everything strapped down as tight as we thought we did for that Ohmsburg. It is now.
Okay, copy.
Sorry, OMAC burn. Sonny corrected me.
Well,
In the shuttle days.
yeah, we knew what you were talking about, or at least I did. So did Dean.
I knew Dean would know. And I bet Van Sice knew as well. He's a little bit of a graybeard himself.
Yeah, I can confirm his beard is a little gray.
And Sonny says, of course, Vincent, he would not know. He's still a little baby.
Copy that. Starliner Houston Air to Ground 1, just pulled go for integrated operations down here.
Outstanding. Did we ever mention how great this trad zoom is?
I bet it is. I enjoy it.
Starliner flight control team getting ready for the integrated go/no-go for integrated ops with ISS. That integrated set of calls should be coming up in just under 5 minutes from now.
With that recent go for integrated operations, teams will soon begin setting up the Big Loop. This is essentially a communications pathway that allows both this mission control room that you see on your screen here, the White Flight Control Room, where Starliner is being commanded, and the International Space Station Control Room to speak with both Starliner and the space station itself as we get into those proximity operations. We're now less than about 8 minutes away from the NHPC-2 burn. Again, this burn changing the plane of the spacecraft. And we are just a little bit over 3 hours until contact with the International Space Station. Again, targeting docking for 11:15 a.m. Central Time.
Expecting the two flight control teams to start their go/no-go poll here in just under a minute. In the meantime, Starliner is changing its orientation to unlock for in thrust align mode, which will keep Starliner pointed in the correct direction to perform its NHPC-2 burn. To finish. The NHPC-2 burn is just a small adjustment post NHPC-1 burn. little bit more fine alignment on Starliner's apogee, its highest point, its altitude, as well as any small adjustments needed for any misalignment in the two orbital planes between ISS and Starliner.
Starliner is currently flying autonomously, meaning it needs no input from the crew to continue making its way.
Starliner, go for the NHPC-2 burn.
Outstanding. Go for an HPC 2.
Continuing to hear good calls from the ground teams to the crew that Starliner's rendezvous can proceed as normal, again targeting that NHPC-2 burn, time of ignition in just about 5 minutes. And again, this is an automated burn, but once we get up to a 260-meter hold point from the International Space Station, Butch and Sunny will take control of Starliner once again. They get another opportunity to fly the spacecraft for another manual piloting demonstration. That's the second of two. We had one yesterday where the crew was in far-field operations, so quite a distance away from the International Space Station. This one, because that one went so well, is conducted in proximity operations, or as we get a little bit closer to the space station. After the manual piloting demo is complete, the spacecraft will be transitioned back into an automated mode and continue with the rendezvous and docking procedures.
up on 1 minute until the start of the NHPC-2 burn. Starliner is now reaching just right at 70 kilometers away from ISS at a closure rate of about 97 meters per second. And we're burning. And NHPC burn cutoff.
Good burn, Starliner.
Good burn. Yep, we were a little behind on our prop numbers, and now we're a little ahead.
Now that NHPC-2 burn is complete, there's just a small...
All right. Butch, yeah, copy that.
NHPC-2 burn just being a small adjustment to the NHPC-1 burn. Starliner is now on a trajectory to reach about 409.9 kilometers altitude, just underneath ISS approach ellipsoid.
The next burn for Starliner and its crew of NASA astronauts Butch Wilmore and Sonny Williams comes in about 22 minutes. A little over that, we will be looking for the NSRPC burn. This burn will make the spacecraft co-elliptic with the International Space Station, meaning it will be at the same distance below the space station all the way around the Earth. There's not going to be an apogee or a high point or a perigee or a low point for Starliner at that point. It will continue below station about 3 kilometers below at that time.
Okay, Houston, we have reviewed manual breakout, and we are now within step 13.
All right, yeah, copy that, thanks.
less than 15 minutes away from the NSRPC burn. This is a burn that will make Starliner co-elliptic with the International Space Station, meaning it will be about 3 kilometers below the space station during its orbit around the Earth. We're also about 2 hours and 50 minutes away from our estimated docking time, again targeting 11:15 a.m. Central Time this morning. The crew woke up at 3 a.m. Central Time after having about 8 hours of rest. We've heard from them several times this morning. They are continuing to monitor the flight. And teams here have pulled go for docking to the International Space Station.
And Butch and Sunny, good morning. Neil stepped off, and your trusty backup's here. And Ray says the Vistas are awesome, and so is he.
That last part we knew. As is the rest of the team.
Starliner Mission Control here in Houston. Thanks for joining us for the first rendezvous and docking of Boeing's Starliner spacecraft with the International Space Station. I'm Boeing's Jim May.
And I am NASA's Leah Cheshire.
In a few minutes, we'll go across the hall to International Space Station Flight Control Room for a look at today's activities from that perspective. Needless to say, there will be a lot going on.
Good morning, both of y'all. I really liked that launch. That was the first time I saw a Starliner launch, and I was really proud and happy that my two very good friends were on board and in good hands. It was a beautiful launch. There was a cloud in the way, so you went up into a cloud, and I thought that was symbolic.
You mean a cloud between you and the rocket?
That's affirmative. So you just ascended into heaven, as far as I knew.
Well, I can tell you, we didn't quite make it that far.
Well, it's great to hear you on the loops today, and very much looking forward to docking later on. Good luck.
Thanks, Spanky. It's great to hear your voice too. And I'll just be honest, as we were accelerating there on launch, I thought about you and just thinking that of your crew, and you guys are going to be coming soon after us. So thanks for tuning in this morning.
There'll be a lot going on here, both in the White Flight Control Room and in Vicar 1 with the ISS Flight Control Room. We'll bring it all to you here as it happens some 250 miles above Earth. Right now we have Starliner just over 10 kilometers away from the space station, and it's a little bit below and behind as we're catching up to do the
And using that earlier comment about the duty cycle and mostly in roll, I'll have to admit that it's also quite noticeable in yaw as well.
All right, copy.
Good morning. Getting a few words of encouragement from Mike Fink, but we're following Starliners that's coming up behind and below ISS as we get near the approach ellipsoid.
This mission began almost 23 hours ago.
And Starliner Houston, just two things consumable-wise. We're tracking per the predicts on prop, ecom, and MPO. So we're in a good shape there. And then also we've got good targeting at good config for the NSRPC burn. So we're going to go for the burn.
Outstanding. Appreciate all that. Go for NSRPC. Good to see.
Good news going up to the crew members. We are targeting the NSRPC burn in about 3 minutes 45 seconds. Again, that will make Starliner co-elliptic with the International Space Station all the way around the Earth. Again, we had liftoff yesterday from Space Launch Complex 41 at Cape Canaveral Space Force Station in Florida aboard a United Launch Alliance Atlas V rocket that liftoff at 9:52 a.m. Central Time. Since then, the crew has conducted some demos along the way. Starliner has been steadily raising its orbit on a precisely timed course to dock to the space station, now coming up in about 2 hours and 38 minutes.
to recap a little bit of what we've been tracking on the Starliner since launch. Prior to launch, our team had been monitoring a small helium leak in Starliner's propulsion system. Teams have been taking a closer look at that system before the crew went to sleep. They closed all the helium manifold valves to collect data and observed two other small leaks. One in port 2, one in port 1, and one in top 1 manifolds. The ground made the crew aware before they went to sleep for the night, and the team's been working on it while the crew rests. The original helium leak that we were monitoring prior to launch was the one in port 2, but after we've tested all 8 of Starliner's helium manifolds, we found that the leak was isolated to just one flange. It's in one of the spacecraft's 28 reaction control system, or RCS thrusters, which makes small adjustments on orbit. Even more specifically, that was found to be in a tiny seal, where the seal is about the size of a button on a dress shirt. Overnight, they kept the top 1 and port 1 manifolds closed, and they opened port 2 later. It gave the teams on the ground the ability to manage the spacecraft. We do have confirmation from our engineering support teams that the helium system remains safe for flight. This isn't totally unexpected. We plan for cases like this, and the team's working to make sure we're in a good configuration and complete our mission. Earlier, before we got closer to integrated ops, we did have the engineering teams note that we've got over 90 hours of available free flight time in that helium system, and that will be 90 hours after undock. And as we've been nearing station, Starliner has been using its Vesta camera system as we were around 100 kilometers away from station. Starliner picked up ISS on its cameras, a small dot in the distance. We've been using that narrow field camera on Vesta, the vision-based electro-optical star tracking assembly, to measure the distance between Starliner and ISS and use that to help give Starliner a better estimation of where it is and where it needs to go for our planned docking around 11:15 a.m. Central.
We're standing by now again for the NSRPC burn. It's coming up in about 10 seconds. Again, this is an automated burn. The capsule is flying itself right now. This comes after the NHPC 1 and 2 burns occurring on time and nominally just previous to this. Confirmation the burn has begun, and we have 4 good OMAC thrusters firing.
And we've got cut off.
Starliner, good burn, and go to configure for space to space and try a comm check with ISS on the big loop.
Again, we had confirmation of a good NSRPC burn with those OMAC thrusters. That's orbital maneuvering and control. The next will be a go-no-go for the TPI burn.
Loud and clear. We have you so loud and clear. We're ready for you. Come aboard.
Hey, can you guys see us yet?
We're about to go look out the windows right now, although they're telling us to close them soon.
Try to get a good picture of us quickly. We can't wait to be there. Very to hear your voice, Mojo.
Sonny Bush, so good to hear you. Can you see us? We haven't looked out the window yet. We're about to. We do appreciate that permission to come aboard. Thank you. I'm flashing me all this light signals, Bush. We'll be looking.
And Starliner, Houston on the big loop. Copied, good. Comcheck to station. How me?
Have you the same, loud and clear?
Yeah, loud and clear as well down here.
Neil, we can hear your voice as well. Great big loop comm check. A little bit non-standard, but we wanted to hear our friends. It's amazing. Thanks.
Yeah, same here. Super excited.
Starliner MCCH on the big loop. Howdy here.
CCH, Starliner, we have you leaving Charlotte. How many?
I have you loud and clear as well. Station Houston on the big loop. Since big loop is now set up on 2, we're going to move station calls over to 3.
Station copy.
As you just heard, some conversations between all of the players in today's...
Houston copies, tally up.
Station copies the tally. We're still looking. Looks so little from here. Give us a flash. Just a signal on the window. We'll try to find you. I think we're a little below you. Your solar arrays are goalposts right now for us.
Again, with those big loops configured, that means the space station, Starliner, and both flight control rooms can all speak with each other as we get into proximity operations.
Station visual. You saw my signal.
Butch Wilmore has confirmed he can see the International Space Station from Starliner, again traveling about 13 kilometers away from the space station at this time and scheduled to dock at approximately 11:15 a.m. Central Time.
Right on to you. Okay, I'll put that in work shortly. I'm going to grab my iPad and get it in work. Was that 1268? Dyslexia 1286. Thank you.
Now with the big loop configured and we are getting into those integrated operations, it's not just the Starliner mission control room here who is tentatively watching the arrival to the International Space Station today, but the International Space Station team is as well. So I'm going to toss it over to my colleague Gary Jordan just across the hall.
Expected for the timeline and the timeline tool. Roll pitch yaw 179, 173, and 4.
Of Butch and Sunny to the International Space Station. Now, here in the International Space Station Flight Control Room, monitored 24 hours a day, 7 days a week for the International Space Station operations. We're now in integrated operations with the teams down the hall in the White Flight Control Room. Here in Mission Control Houston, the team is led by Flight Director Vincent LaCourte. Sitting next to him is Diana Trujillo. And over the Capcom voice that you'll hear today from the room is Will Vu. Now coming into frame, Vincent LaCourte, the flight director that's leading the teams here today for rendezvous and docking. With integrated operations, you've heard some of the setup that's needed in order to enable that. That includes the enabling of the big loop. So now all teams, including the 2 flight control rooms here in Houston, as well as the 2 vehicles in space, the Starliner and the International Space Station, now all talking on one big loop. The teams have both go for integrated operations, and now, in the next 5 minutes, the teams here in International Space Station Flight Control Room will pull a go, no-go for the TPI burn. This is a burn that brings us into the approach ellipsoid. Once we're in the approach ellipsoid, it'll be a carefully choreographed series of maneuvers to get Starliner to the very forward port of the International Space Station. Space Station is in an attitude configuration ready to receive the Starliner. The solar alpha rotary joints that control the solar arrays of the International Space Station are locked and feathered. They're in a position ready for the rendezvous operations. Here in Mission Control, Houston, International Space Station teams are polling again go for that TPI burn. We're in integrated operations monitoring things, and from the everything looking good. With that, we'll continue to follow along with the teams over at Flight Control Room looking after Starliner and its systems. Leah and Jim, back over to you.
Thanks, Gary, and we will continue checking in with Gary and the team in the International Space Station Flight Control Room. Again, we are just across the hall.
Is a little fragmented. You got a chip in the B chip slot, and it won't record.
It's from a memory chip, and it will not record. I tried to do it through the laptop. It's just on the camera itself.
Okay, we'll have to check.
Told her that it had to be in C. So for some reason the camera's not safe.
Okay, good.
In the center of your screen here, up to the right in the light blue shirt, that is Flight Director for Starliner today, Ed Van Cise, and to his right is the bottom of the screen is the Capcom, Neil Nagata. Neil is the voice you'll hear speaking with the astronauts aboard Starliner. He funnels all the information coming from the flight controllers and teams here on the ground and shares that with the crew members. That way they're getting a single point of information as they continue through today's operations. Up on a go, no-go poll for the TPI burn. That's the terminal phase initiation burn. We will leave the co-elliptic burn that we have been keeping since the NSRPC just a little bit before, just about 10 minutes ago, really. We will conduct this TPI burn, which will also bring us inside the approach ellipsoid. The approach ellipsoid is a 4 kilometer by 2 kilometer by 2 kilometer invisible boundary around the International Space Station. It's the first of 2 that we will see today. It helps teams monitor the arrival and departure of visiting vehicles, whether they're carrying crew or cargo.
Regions around the station have an analogy on the ground. The approach ellipsoid is pretty similar to regional air control that you might see around a city, and the keep out sphere, which is the closer region around ISS, is a lot like the airspace around an airport that you have to get permission to fly into before landing, just like we do for docking the space station.
A good center line camera picture. Lines up.
Roger. Roger.
We heard configuration from the crews aboard the space station and Starliner that they can visually see each other, but Starliner systems, the Vistas system specifically, which stands for Vision-Based Electro-Optical Sensor Tracking Assembly, that also has tracking the space station as well. These are technically like the eyes of the spacecraft and will continue following the outline of the space station until it can hone in on the docking port. Today, Starliner is docking to the Node 2 forward port, which is where one of the international docking adapters is located. Again, we are tracking docking at about 11:15 a.m.
On the big loop for the center line camera.
Go ahead.
Hey, Butch, the config we think we have is there's no card in slot A, card in slot B. I'd like you to pop the card out of slot B, take a look and see if there's like a write protect switch. It looks like a little lock on the SD card, and see if that's in the lock position, and if it is, you can toggle that back, put it in slot B. If it's unlocked, we can go ahead and try slot A.
We'll give it a shot. Thanks.
Starliner Houston on the big loop. Your signal is Charlie. You are go to command the AEATP.
AATP, here we go. AATP is available.
We see the same.
Butch Wilmore entering the AEATP into Starliner's flight control system. That stands for Approach Ellipsoid Authority to Proceed. That will allow Starliner's automated flight system to approach into ISS approach ellipsoid after agreement from both the ISS flight control team and the Starliner flight control team.
Starliner Houston big loop. We just wanted to let you know that when we're manipulating that memory card, we'll make sure the centerline camera is off OFF.
Yeah, it's off. We're doing that.
Roger.
Starliner will not go into the approach ellipsoid until after the TPI.
Right protect switch, so the other setting in which she put it back in the camera and then turned the camera on, it still is asking for A. Is there a way to do that anywhere?
Go ahead and just try A.
A little bit of troubleshooting. On Starliner's centerline camera. The centerline camera is a secondary source of visual information that the crew uses. It's a camera mounted in the center of the forward docking port on Starliner. It feeds video data directly to the crew's procedure tablets. They also are recording some video for that as part of the flight tests for this mission. That camera will be used more as the crew gets a little bit closer to station. And they're doing this troubleshooting as we are nearing the TPI or terminal phase initiation burn, and that is planned to come up here in about 6 minutes.
We've heard multiple voices and seen some of our team members in the room here today, but to tell you a little bit more about our NASA astronauts aboard Starliner. Again, this is the first flight of astronauts aboard this spacecraft. We're talking about Butch Wilmore and Sunny Williams, the commander and pilot, respectively, of Starliner.
Roger that.
Commander Butch Wilmore was raised in Mount Juliet, Tennessee, and is married to Deanna Wilmore, and they have 2 daughters. He has a Master of Science in Aviation Systems from the University of Tennessee. The U.S. Navy captain successfully completed 21 combat missions during Operation Desert Storm while operating from the flight deck of the USS Kennedy. Butch has accumulated more than 8,000 flight hours and 663 carrier landings. NASA selected him as an astronaut in July of 2000. So far, he's completed 2 space flights. This is his 3rd. His first was a pilot on the Space Shuttle Atlantis in 2009, and in 2014, he served as a flight engineer for Expedition 41 to the International Space Station. To date, Wilmore has logged 178 days in space, and I think we can chalk that up now to 179, including 4 spacewalks. This will be his 3rd mission to the International Space Station. Before his selection to NASA, Wilmore was on exchange to the United States Air Force as a flight test instructor at the Air Force Test Pilot School at Edwards Air Force Base in California.
And Sunny Williams, the Boeing CFT pilot, was selected to be an astronaut by NASA in 1998. Like Wilmore, this will be Sunny's 3rd mission to the International Space Station. In her previous 2 flights, she served as a flight engineer for Expedition 14, and in 2012 as a member of the Expedition 32 crew. She's logged 382 days in space, including 7 spacewalks. Williams has more than 50 cumulative hours of spacewalk time, and that's the 2nd most by a female astronaut. The retired U.S. Navy captain is a former naval test pilot and instructor. She's logged more than 3,000 flight hours and more than 30 different aircraft. Sunny has a Master's of Science degree in Engineering Management from the Florida Institute of Technology. Williams, who grew up in Needham, Massachusetts, is married to Michael Williams. She enjoys hanging out with their dogs, working out, hiking, camping, as well as working on cars and houses.
And the crew woke up this morning at about 3 a.m. Central Time, just about their scheduled time after about 8 hours of rest overnight. Once they get to the International Space Station, they'll be joining 7 crew members living and working there. Currently living aboard the International Space Station are NASA's Mike Barrett, Matt Dominic, Tracy Dyson, and Jeanette Epps, plus Roscosmos cosmonauts Alexander Gurbenkin, Nikolai Chub, and Oleg Kononenko. That's the Expedition 71 crew. So once Butch and Sunny arrive today, we'll be up to 9 crew members aboard the International Space Station.
Starliner Houston on a big loop, be advised that's for both. No action, RCS jet S2A2 fail, still go for the burn. It failed off, Butch, and right when that was happening, I was calling up, just be advised, neither of the infrareds are taking measurements now for RailNav, so we're gonna go ahead and reboot the camera IR1. Backup enable 2 for this jet fail.
Enable 1 off, enable 2 on.
We are about 30 seconds now until the terminal phase initiation burn. Again, after completion of this burn, Starliner will move into the approach ellipsoid.
And the burn has started.
Starliner, good TPI.
Good TPI.
And Commander Butch Wilmore and the flight control team here noting a good TPI burn. Just before that burn, there was a call out about a RCS jet fail. The meaning behind that message is that we have been monitoring the thruster, and while it had good performance, part of our kind of conservative set of sensor data around the health and status of that thruster, something was slightly out of the planned ranges for that, and so as a safety precaution we turned that off. But during our last check it was performing as intended. Starliner has multiple redundant sets of thrusters. As a precaution, we've turned that one off. There are procedures to turn it back on and do a checkout when we're not close to a bird coming up.
Starliner is approximately 700 kilometers away from the International Space Station. The orbiting laboratory is currently flying about 17,000 miles per hour, 260 statute miles over Iran. We've walked through a handful of burns this morning. The first of those, the NHPC-1 burn at 7:52 a.m., changing the height of Starliner, and the second of those, the NHPC-2 at 8:14 a.m., also fine-tuning its approach to the International Space Station. We saw the NSRPC burn at 8:38 a.m. Central Time. This made the Starliner spacecraft co-elliptic with the International Space Station, and the terminal phase initiation burn was just conducted right on time at 9:02 a.m. Central Time. This will move Starliner into the approach ellipsoid. That's the 4 kilometer by 2 by 2 kilometer invisible sphere around the space station that helps us monitor arriving and departing spacecraft. All of the burns this morning have been according to plan. Again, Starliner is currently flying autonomously, so flying on its own. We will see, however, Butch and Sunny have the opportunity to take control of the spacecraft and conduct another manual piloting demo once we're about 260 meters away from the International Space Station. This is a test flight, so we want to give the crew an opportunity to see how the spacecraft flies, should they ever need to take control of it. Once that manual piloting demo is complete, they will transition back over to autonomous power. The spacecraft will then continue its approach to the International Space Station all on its own. And again, we're targeting docking at approximately 11:15 a.m. Central.
We're coming up on the
Houston, on the big loop. Hey, we just started picking up RELNAV measurements on both IR cameras. That's when it went to silhouette track at 7,000 meters. Prior to that, in long range track, we were not getting any measurements. We don't understand why we weren't getting measurements, but it's good that we are now getting measurements. But since we have that behavior, we had the conversation here on the ground that, of course, as you know, if once we get into eclipse here, if we go RailNav degraded then diverge, the spacecraft will drop down to manual, and you're going to have to take us up to 200 meters per 11.11.301. And we expect to have good comm through that time period, and we'll give you updates should we see any other behavior or bad behavior.
We absolutely copy all. Right now we got Vesta 1 and 2 degraded, but we're still converged.
Yeah, okay, copy that, and rail nav is good.
Good rail nav.
And Starliner, those Vesta degraded signatures, health and status thing out of the Vesta due to some VEX faults earlier. And RNAV is still converged.
Houston Station on 612, the Yeti Bay backup Yeti Bay swap is complete. And I guess that means that the compressor hose is just going to go to initiate transfer. My bad. Sorry about that. Copy.
And as Starliner is approaching station, getting closer to its IF1 or inbound fly around 1 maneuver coming up in about 35 minutes, you've heard some back and forth between Commander Butch Wilmore and Capcom Neil Nagata. Starliner's Vestas system is currently tracking both the position of ISS, but now that we're close enough, you're seeing some of the outline of ISS.
Roger that.
The Vestas system has a series of cameras, some in the visual spectrum, some in infrared. This will allow Starliner to help track ISS both in the Vestas system will help track ISS both in darkness and light. The red circles showing up on the Vesta display are the Vesta system picking out features on the ISS. When Vesta can pick out specific features of ISS via image recognition, that information can let Starliner know which direction Starliner needs to align with, which will pick Starliner's orientation to be in the optimal position to keep tracking ISS, and will follow that all the way into the docking port.
That view on your screen, coming from the Vesta system aboard Starliner, now checking out the International Space Station. You can see it coming into view pretty well. And of course, we are monitoring Starliner's journey here in the White Flight Control Room at Johnson Space Center in Houston, Texas. But over across the hall in the International Space Station Flight Control Room, NASA's Gary Jordan is continuing to monitor the station side of today's operations. Gary, can you tell us how things are going?
Hey Leah, things are going very well. We're following along every step of the way with you down the hall in the White Flight Control Room here in what's called Figure 1, or the International Space Station Flight Control Room. Teams here led by Flight Director Vince LaCourte, watching over the crew aboard Starliner, as well as the Expedition 71 crew that's aboard the International Space Station. Crew members split up doing different things. It's Matt Dominic that you see there on the graphic on the front right there, NASA astronaut who's responsible for enabling the monitoring tools necessary to watch Butch and Sonny approach the International Space Station. There are tools, there is software that is receiving data from the Common Communications for Visiting Vehicle, or C2V2 system, that creates a link between the International Space Station and Starliner. It's Matt Dominic there you see in the front that's going to be following along with that. Later, we'll have Matt Dominic as well as Tracy Dyson in the back left there. She's a NASA astronaut, flew up with the Soyuz crew, including Chub and Kononenko, Nikolai Chub and Oleg Kononenko. Kononenko, of course, who just passed the milestone of 1,000 days cumulative in space. On the left there, you see Alexander Gubyankin, who is the cosmonaut that joins the Crew 7 crew in the very front of this graphic. To the right in this graphic is Mike Barrett, and on the far right, Jeanette Epps, making up the complement of 7 astronauts and cosmonauts of Expedition 71. It'll be Tracy Dyson and Matt Dominic that oversee the final moments of the rendezvous operations through the docking of Starliner to the very forward port. Once they do dock, the International Space Station flight control teams here in the International Space Station Flight Control Room will work with the teams down the hall in Starliner Flight Control to walk through the hatch opening sequence and operations. The 7-member crew that we just talked about will be there in the Node 2 forward hatch, ready to welcome Butch and Sonny, the first crew members to fly Starliner to the International Space Station, and we'll conduct a welcome ceremony from there. Here in the flight control room, we talked about Vince LaCourte, the flight director. Next to him is the Capcom, Will Vu. You'll hear his voice relayed up to the crew aboard the International Space Station. Right now, all crew members are talking in the Space to Ground 2 loop, which is a big loop. Everybody here that you're in the flight control rooms, both rooms here in Houston, the Space Station Flight Control Room and Starliner Flight Control Room, are talking with the 2 spacecraft that are about to rendezvous here coming up in the next couple of hours. Will Vu there is responsible as the voice from the control rooms here to talk with the crew aboard the International Space Station. Most of the communications you'll hear from him will be relaying to Matt Dominic, who again will be overseeing the rendezvous operations. Neil Nagata on the left there will be responsible for talking with Butch and Sonny in Starliner. Everything is coordinated as part of the integrated operations, very carefully choreographed procedures that you'll hear to make sure everybody's talking and the rendezvous operations are going swimmingly. So again, everything in the International Space Station Flight Control Room is going according to plan. We're tracking down to some of the next burns here, the inbound fly-arounds, which, of course, as after the TPI burn, terminal phase initiation, we get inside the approach ellipsoid. Once we're inside the approach ellipsoid, we operate by these joint flight rules and count down towards these next sequence of burns to get ever closer. It'll be very interesting to see some of the great visuals for some of the free flight demos that are necessary to verify all of the different capabilities of Starliner as part of this flight test. Again, station is ready to receive the Starliner. We're tracking no issues at this time. Attitude and solar configurations aboard this station is ready, and so really we're just following along every step of the way with the teams over there in the Starliner Mission Control Room. So that'll be it for us for now. We're continuing to follow along, and we'll be with you every step of the way. Leah and Jim, back to you over in the White Flight Control Room.
Thanks, Gary. And yes, we continue to monitor the arrival of Starliner to the International Space Station. And if you're just joining us, a reminder, this is the very first flight of Starliner with crew members aboard. So we'll be bringing the space station total number of crew members up to 9 upon their arrival today, again targeting approximately 11:15 a.m. Central Time. And as we get closer and closer, the Vestas system aboard Starliner, which is the view you're seeing right now, will continue to give us an even more defined look at the International Space Station. It's getting even easier to make out those individual solar arrays at this time. And as we get even closer, we'll stop tracking in silhouette mode and begin tracking the docking port itself. Again, we're going to the forward docking port today. It's the Node 2 forward port, where one of the two international docking adapters is located. To take a look at the rendezvous and docking profile today, we've had two height adjustment and plane change burns already. Those are the NHPC 1 and 2 burns occurring at 7:52 a.m. and 8:14 a.m. Central, respectively. Those were both good burns. We then came up on the NSRPC burn. This was a co-elliptic and plane change burn at 8:38 a.m. Central, another good burn, before moving to the terminal phase initiation burn. This will bring Starliner inside the approach ellipsoid, that invisible boundary that we monitor outside the International Space Station. And we are coming up next on the inbound fly around 1.
The inbound fly around 1 maneuver will swing Starliner out in front of ISS in the direction that ISS is flying in orbit. Then the IF2, or the inbound fly around 2 maneuver, will slightly alter Starliner's trajectory to hit a peak altitude in front of the Node 2 forward docking port. From there, Starliner...
Big loop for tablets. We can take another reseat on the tablet that's charging, and we're also curious on the battery status of the tablet you're using for centerline camera.
On camera, 80%, it says 2 hours left. One that's on the chargers is 71.
Did you say the centerline camera tablet's currently on the charger?
It right now, the centerline camera is now going on the charger. The other tablet, which I have in front of me, which has full, is 71.
Copy that. And can you tell what the centerline camera battery state of charge is?
Well, I got to get out of my seat to look at the centerline camera, so let's just wait till we get LiDAR acquisition.
Starliner, expect LiDAR acquisition in about 400 meters.
Plus fully charged at 190 minutes.
Okay, copy that.
We're showing R-bar cross about 1200.
We agree.
some of the communication going between Capcom and Commander Butch Wilmore and pilot Sonny Williams is about making sure that the battery of the centerline camera and the batteries on the crew tablets are topped up. Part of the use of those two things is when we begin our just after the inbound fly around maneuver, we will start to approach ISS. We'll start in the corridor approach, where then the crew will do one of their manual piloting demos, where they will do a hold out around the 250 meter mark out in front of station in the approach corridor. After about 5 minutes of that test demonstration, Starliner will then go back to automated mode. We'll hold around the 200 meter mark out in front of station, and then they will get approval to go inside of the keep out sphere. From there, Starliner will make a slow approach, very fine control, down to about the 10 meter mark out in front of the Node 2 forward docking port. From there, Starliner will activate its NDS or NASA docking system. They'll change the flight control rules to an even finer, small, discrete set of thruster settings, and then we'll go in for a final dock at around 11:15 a.m. Central.
Starliner, good LADAR acquisition.
Good LADAR.
Starliner is now picking up ISS on its LADAR sensors. This is giving Starliner a good 3D picture of ISS in the distance. I gave a brief overview of the burns that are coming up, but let's take a closer look at the full docking profile for Starliner as it approaches ISS.
Starliner. Quick question. On the big list.
And Butch, I'll take it. I don't know if you're looking for Will.
I was, but I'm just curious what their external lighting config was. If they've got their lights full up and on or not.
Yeah, Butch, station's external lights are off OFF.
That's what I figured. Mojo on the satellite channel.
Starliner continuing on its way up to the getting ready for the IF-1 burn.
Can you see the ISS center centerline camera on the tablet?
Oh, that's what I'm saying. I can't see it at all on the satellite camera. We've got a good picture on the IR camera, but centerline there's nothing. Played with the auto and the manual gain. I mean, I can see the pedal. I think it's getting some reflection from inside the cabin here, but I cannot see the ISS.
All right, yeah, copy that, and Spanky reminded us that you can take a picture or screenshot on the tablet. And in other news, you are go to Command and KOS ATP.
We've taken several screenshots and videos, and KOS ATP, here we go.
All right, copy.
KOS ATP is enabled.
Here's your copies.
And as part of the process,
We got sunrise coming in 15 minutes.
Okay, yep. Hey, actually, just looked that up. Thank you.
and as we're approaching the IF-1 burn coming up here in 10 minutes, Butch Wilmore got the go-ahead to, or the authority.
I don't know how hard it is for ISS to get their lights on, but it might be a good check to see if it's visible with the lights on, since it's not without.
Yeah, we're checking, Butch.
And we're coming up on around 25 seconds till expected approach ellipsoid entry.
Again, the approach ellipsoid is a 4 by 2 by 2 kilometer invisible boundary around the outside of the International Space Station. And confirmation, we have entered the approach ellipsoid. As Jim was saying, we also heard the authority to proceed to the keep out sphere.
Turn the light on because I can now see there is a speck out there.
Station Houston on the big loop for the ISS cruise awareness. Starliner is inside the approach ellipsoid.
Station copies.
Again,
We're still talking about turning on the lights here on ISS. We haven't turned on any yet.
I get some reflection, looks like on the aft end, something. Might have was shining a flashlight out the cupola, I don't know.
Yeah, copy.
as we were saying, we have recently heard the authority to proceed to the keep out sphere. We expect the Starliner spacecraft will enter the keep out sphere around 10:35 a.m. Central Time, so a little less than an hour from now. That keep out sphere is another invisible boundary, this one with a 200-meter radius around the International Space Station. To enter the keep out sphere, we must agree that the spacecraft could, for some reason, lose control of its thrusters and still not enter that boundary for 24 hours.
Turning on the Cedar lights.
That's great.
However, before we enter the keep out sphere, we will do a hold at 260 meters at approximately 10:24 a.m. Central Time for another manual piloting demonstration.
And while Starliner's Vesta infrared camera is able to pick up station, we're currently still in a period of darkness. You heard Commander Butch Wilmar talking about it being a little difficult to pick up the station on the centerline camera, which is a visual spectrum camera. The ISS team's trying to see if they can get the ISS team to turn some of the ISS lights on to make it a little bit easier to pick up the station in using regular eyesight, but we will be coming up on a period of daylight in about the next 20 minutes or so.
We are now about an hour and a half away from our scheduled docking time this morning, again targeting 11:15 a.m. Central. That comes after launch yesterday at 9:52 a.m. Central.
And Butch, Houston on the big loop. We've got one seat of light coming on, and there'll be 4 more coming on. It might take a little bit to warm up.
I see the first one. I saw it when it came on.
Okay, you saw that in the centerline camera?
Affirmative.
And you know what's coming. We're going to want some centerline camera screenshots of that.
We heard some communications between the Capcom and the crew aboard Starliner. They are turning some lights on the International Space Station. This will give the crew a better visual of the station itself as they continue to approach. We are standing by for the IF-1 burn in about 1 minute and 30 seconds. This is the inbound fly-around burn.
This inbound fly-around 1 maneuver is going to be performed with the RCS jets. This burn should last about 18 seconds.
The RCS jets that'll be executing this burn are on the service module portion of the spacecraft, and if you look in the top right corner of your screen, that is what it looks like is facing you, the service module portion. This part does not return to Earth. It is disposed after the deorbit burn, nearing the end of the mission. The only portion that will return to Earth is the crew module. That's where Butch and Sunny are seated right now. It'll parachute to a landing in the southwestern United States.
And we're coming up on 10 seconds to the IF-1 burn. And thrusters are firing. And thruster cut off.
Good burn, Starliner and Butch. We got all 5 seat of lights on for ISS. How does it look?
Yes, we can see it. I cannot make out the width, however. We can't see the station.
Yeah, but can you clearly see like the distance between the two outboard lights?
You can see the one that's on the port side. I cannot see the one on the starboard side. It might be blocked by something.
Roger.
And we heard Starliner had a good IF1 burn. With that, we have an expected IF2 burn. Small adjustment to place Starliner to start flying towards the approach corridor for the Node 2 forward docking port. Now that IF2 burn is coming up in about 18 minutes. Still some issues picking up the lights on ISS.
Starliner had a transient caution around the time of the burn. No action. It was just sort of expected, and there was timing with how the triggers were set up for that message.
Hey, yeah, we copy. We saw it.
That IF1 burn coming right on the timeline at 9:47 a.m. Central Time. We are targeting docking with the space station at 11:15 a.m. Central.
And you heard Commander Butch Wilmore talking a little bit about trying to pick up the lights on the outside of station. We should be coming up in a period of daylight soon, and that should hopefully help them see station without the extra lights, but also...
Roger that, inside 2 minutes sunrise.
And you heard sunrise coming up in about 2 minutes. Should help both Butch and Sunny see the station with their own eyes, as well as the visual spectrum cameras pick it up as well. Currently sitting just over 530 meters away from station.
Now we do not have views currently of the crew inside the Starliner capsule. However, we will regain views of Sunny and Butch once they dock to the International Space Station. We also do anticipate to start getting views from the space station itself looking down on Starliner as it continues its approach. Again, the next major milestone this morning is the IF2 burn, coming up in about 15 minutes. That places us on the docking corridor. That means we're directly in front of the docking port. Node 2 forward port, which is where one of our two international docking adapters is located. And as we transition from an orbital nighttime into an orbital daytime, teams reporting that they are getting all good views on the Vistas system. This is the system on Starliner that allows us to track the space station, and as we get closer will help us align with the docking port. This view inside the White Flight Control Room here at NASA's Johnson Space Center in Houston, Texas. Teams are taking the opportunity to take a very quick break before we get into the docking operations. And with good views coming in on the Vistas system, let's learn a little bit more about the eyes of Starliner. And these are views live right now from Vesta. As you can see, we are getting more and more detail from those cameras. You can even make out some of the IROSAs, or the International Space Station Rollout Solar Arrays, atop the original arrays on the top right and the bottom left of your screen. And we have our first views of Starliner from the International Space Station, now crossing over into an orbital daytime over the South Pacific Ocean. We are tracking docking this morning at 11:15 a.m. Central Time, the first arrival of Starliner to the International Space Station with NASA astronauts aboard.
Starliner Houston on the big loop. Just letting you know, now that we have light outside, we're going to turn off the CETA lights just in case.
Concur. Thank you.
Now that we're into an orbital sunrise, teams here in Mission Control have let the Starliner crew know they are turning off the lights on the International Space Station side, since it seems like the crew aboard Starliner now has a good visual on the station itself. Again, Starliner is flying autonomously right now, but we will see the crew transition to manual piloting at about a 260-meter hold point, giving them a chance to take the reins of Starliner.
Starliner, see the B1 Bravo 1A3 jet fail. Still taking a look at it.
Copy, we saw.
Yeah, and it failed off.
Airfield 2, we're up to 14 marks. 50, 16, 17.
Okay, copy.
Want us to get rejected or not?
Yeah, don't need to reject it yet. Butch, Ray's looking at it.
All right, we're up to 35.
Roger.
You're looking at a live view of Starliner as it approaches the International Space Station on NASA's Boeing crew flight test with NASA astronauts Butch Wilmore and Sunny Williams aboard. I'm NASA's Leah Cheshire, joined by Boeing's Jim May, and we are continuing to track the first flight of crew aboard the Starliner spacecraft. Starliner lifted off yesterday at 9:52 a.m. Central Time. Since then, the spacecraft has made several maneuvers up to the International Space Station, and it is now on the docking axis following the inbound fly around 1 burn. We're standing by for the inbound fly around 2 burn coming up in about 5 minutes and 30 seconds. Now, built in over the last 24 hours, the crew has had about 8 hours of a sleep period. They woke up around 3 a.m. Central Time this morning, and we are targeting docking at approximately 11:15 a.m. Central Time. We're live in the White Flight Control Room here at Johnson Space Center. This is where Starliner is being commanded. There at the top of your screen in the light blue shirt, that's Flight Director Ed Van Cise. In the middle of the screen, you can see Capcom or Capsule Communicator Neil Nagata. And down in the white shirt with the red tie, that's NASA astronaut Mike Fink, also a crew member for the Starliner 1 mission. Now, as we are here in the White Flight Control Room in Houston, we have a team member just across the hall. That's NASA's Gary Jordan. He's in the International Space Station Flight Control Room, keeping up with the other spacecraft that we are monitoring today. That's the International Space Station itself. Gary, how's it going over there?
Hey Leah, hey Jim. Really good to be following this flight with you today from the International Space Station Flight Control Room. Teams here are led by Flight Director Vincent LaCourte, working hand in hand with Enven Seiss just down the hall. The two, in synchronized fashion, are walking through the steps very methodically, like a choreographed dance. Starliner's burns have been executed precisely according to the timeline. Everything tracking well on the International Space Station side. Right next to him, you'll see Will Vu. He's the Capcom from here in Mission Control Houston, relaying the procedures and following along with, of course, all of the different operations, but his job is to talk with the crew aboard the International Space Station. 7-member crew is currently aboard and awaiting the arrival of Butch and Sunny. It's NASA astronaut Matt Dominick's job inside the International Space Station to monitor Butch and Sunny's arrival. He's there in the very front, slightly to the right. NASA astronaut Matt Dominick, and of course complemented by the entire Expedition 71 crew. They're following along. The station is prepared and ready to receive the Starliner. We have the exterior lights off. The solar arrays are parked in a configuration ready for the docking, and the attitude is right on track. So we're just counting down, just minutes away from the inbound fly around to burn. And with that, we will send it right back over to you, Leah and Jim, over in the White Flight Control Room to take us through this next burn.
Thanks, Gary, and that's correct. We are standing by for the inbound fly around to burn. Time of ignition expected in about 2 minutes and 35 seconds. Meanwhile, this view coming from the International Space Station, looking directly at Starliner as it moves up to the docking axis.
This IF-2 burn is just a small adjustment from the IF-1 burn. It will help flatten out Starliner's trajectory to get it to point more towards the approach corridor on the Node 2 forward docking port of the Harmony node.
Starliner, go for the IF-2 burn.
Go for IF-2.
And we're go for this IF-2 burn. This burn should only be about 1 second long.
All my data flashing on the flight over dredge.
And coming up on about 5 seconds to the burn. Good burn. And you saw the thrusters fire for the IF-2 burn.
That burn happening right on time, 10:07 a.m. Central Time.
Burn and Butch, say again for data flashing on warp dredge.
The nav FLIR, the white converged, and then 4.02, then inbound fly around, and then the destination A and B in the ARD region. Not all flashing at the same time. Different ones would flash at different times. It's steady now, but it was doing a lot of flashing. Go away, come back. Go away, come back.
Okay. Yeah, that was my next question. Yeah, and good report. Thanks, Butch. We'll have to take a look at that one. And Starliner, we're curious, with that flashing on the parameters, are you comfortable enough that you can command a destination A or B?
Yes, now it's not doing it. I could have done it before as well. Where you actually do the commands, it was fine. Like the abort and recover from those type of flashes, just the white text. And the reason I called you, I know it was right before the burn, but I was hoping to call your attention to it in case it was still doing it. You didn't see it, so my apologies.
Yeah, no, appreciate it. Sorry, we just didn't copy the whole transmission right before the burn.
With completion of the IF2 burn, that's the inbound fly around 2 burn, we are now looking toward the ACI burn in 12 minutes. That's the approach corridor initiation. So at that point, the Starliner spacecraft will be about 300 meters in front of the International Space Station, directly in front of the Node 2 forward docking port where we are headed today. Once we get to the 260-meter mark, the crew will take manual control of the spacecraft and do another manual piloting demo. This time looks like we will have good visuals from the space station to see it. We've now stepped into a satellite handover. The space station uses tracking and data relay satellite systems, and we periodically experience these handovers as we switch from one satellite to the next, but these are tracked and, as you can see, usually very quickly regained.
Roger.
The only issue, there's a fair amount of, I think it's RCS jet residue outside the window.
Okay. Yeah, Butch, we're assuming you're talking out the IVA hatch window for the centerline camera.
That's perfect. I mean, all of our windows had it. It's pretty much covered, but yeah, that one, it's not objectionable. I just want you to know it's there.
Okay, copy.
Starliner continuing its slow approach as it gets near the box to start the ACI burn. Starliner is currently 451 meters away from the Node 2 forward docking port, currently approaching at about 0.22 meters per second.
Sonny just checked the camera battery. It says 134 minutes, three-quarter charge.
Okay, yeah, copy that, and but you should have the battery charge on the tablet overlay itself.
Okay, you mean the camera battery is on the overlay?
Yeah, should be on the tablet.
Always learning.
Roger that. Starliner Houston on a big loop for words for the jet fails that we have. We're planning on doing a hot fire test before we get into the KOS to see if we can get those jets back. And big picture, what that means is that once we get to 260 meters, you're going to go ahead and press through the procedure and put the Starliner in the station keeping inside the corridor. But we're not going to do the manual control demo. You're just going to station keep for us. I'll get you words to get us in a free drift when we're ready. We'll test fire the jets, and we'll see what the data tells us. But essentially, we're just going to be in and out of hold, and you're going to have to do some station keeping in that time frame.
Okay, so at 260 meters, you're going to want me to take manual control and station keep at 260 meters and just hold it there, and then we'll go free on your call. You'll do your jet fire, and then we'll go from there.
Yeah, that's good words. That's good words for now. I'll get you more detailed words once we get there, and we'll have to coordinate that for you. And just be advised, we're gonna want to know if you can hear or feel the jets. So we'll be in back and forth comm during that time period.
And another satellite handover with the tracking data relay satellite systems on the International Space Station. We've just heard some comms to the crew about the plan for 2 reaction control system thrusters that they are troubleshooting. We have an upcoming ACI, that's approach a corridor initiation burn in 3 minutes, 18 seconds and counting. And after that occurs, we will reach our 260-meter hold point. We anticipate that hold point around 1024. This is originally where we were planning to switch to manual mode and go into the manual piloting demo. We are still going to switch into that manual mode and troubleshoot those 2 reaction control system thrusters on the service module by conducting a hot fire test. After that is complete, the crew will have the opportunity to conduct their manual piloting demo.
So the 2 RCS jets that are currently being investigated, they were preemptively turned off by the flight control system with some sensor values that were slightly above the conservative bounds that we have set. So that's the reason why they're going to do a test of those to see if they can bring them back into the active set of thrusters. Looking at the Vesta views on the screen, the upper right camera, or the near field viz camera, is currently in feature track mode. You can see some cyan light blue outlines around different features of the station. That lets people looking at the images know that Vesta is correctly tracking where it thinks and knows.
Go for ACI.
Go for ACI.
Those outlines letting people on the ground know that Vesta is accurately tracking the outside of station. We also heard a call up to Commander Butch Wilmore that the crew is go for the ACI burn. And that ACI burn just started and stopped.
Starliner, good corridor burn. Go for station keeping at 260 meters.
We are coming up on that 260-meter hold point following the ACI, or Approach Corridor Initiation burn, right on time at 10:22 a.m. Central Time. Again, we are tracking 11:15 a.m. as the earliest opportunity for docking today. However, it is a docking window, so we can hold.
Good corridor. Go for station keeping at 260 meters.
Hold at 265. Hold at 260.
Yeah, good readback.
Starliner coming up on 260 meters. Butch and Sunny are going to begin the hold at 260 meters.
Starliner, in this hold for your trajectory, we're looking for about a 10-minute football. Starliner getting ahead here for the hot fire. I want you guys to go ahead and pull up 12.10.218, 12.10.218, step 2 for the hot fire procedure.
Okay, 12.10.218. We had a pulled up. We're looking at step 2.
Okay, roger.
This is a view of Starliner from the International Space Station. The spacecraft is now aligned with the International Docking Adapter on the Node 2 forward port. That's its intended destination today. They are currently holding at the 260-meter mark. This was a planned hold, however, it is being extended to troubleshoot 2 reaction system thrusters.
And Starliner, we see the B2A2 jet failed off. Still talking about it, still good for control. Hey, Butch, we need to sweeten up the trajectory a little bit. Can you give us a couple ups? And Sonny, confirm you've got the procedure pulled up.
And Capcom Neil Nagata flowing a few messages up to Butch and Sonny. They're currently continuing to.
Hey, Butch, for the trajectory, we want to show that we're going to be above the docking axis for 10 minutes.
See that?
The crew's going to continue their hold outside of the approach corridor. Mission and ground controllers continuing to analyze the data coming in from the RCS jets.
Hey, Sonny, are you guys ready to execute the SM hot fire test procedure? We lost another jet, S1A1.
Are ready to execute the procedure. I'm with you on step 2 of 12.10.218.
Okay, you guys are go to execute step 2, and in between the hot fires, please damp rates. Stand by.
The crew aboard Starliner is preparing to conduct a hot fire test of the thrusters that are currently down. Teams here in the room are continuing to work those procedures. Again, we are at a 260 meter hold point.
Starliner, execute step 2 now, please.
Starliner. We see step 2 complete.
Roger. Okay, Starliner, we're about to hot fire S2A2. Stand by. Starliner did a hot fire S2A2. We'll need you to get point back at the target, please. And Starliner, curious if you heard or felt anything for that test fire.
We did.
Roger. All right, we're gonna go for the next one now.
And mission controllers here, working through hot firing the jets that have been toggled off. They're doing them one by one, going back and forth between that and having Butch hover in the corridor.
Ready for hot fire.
Okay, B1A3 was just hot fire. Did you feel or hear anything?
Not specifically.
Okay, we're gonna.
Right again.
Well, we're gonna set up for the next one now.
Flight controllers have conducted 2 hot fires on the Starliner spacecraft reaction control system thrusters. They are now preparing to hot fire 2 more thrusters. Butch Wilmore continues to manually pilot the spacecraft.
Okay, copy that. We'll be on air to ground 1. ISS is in a handover. Loud and clear. B2A2, we just hot fired. That was the one you felt.
That's affirmative.
We'll take talk listen on space to space. We'll go back to the big loop.
In work, changing.
Okay, about to fire S1A1. Stand by.
Aye. Heard it.
Roger.
That completes the hot fire test at the 260-meter hold point. Teams on the ground hot fired 4 of the reaction control system thrusters. These are located on the service module. The crew was able to report they felt all but one of those, or heard all but one of those hot fires.
And the engineering teams here in Houston still analyzing the data they got from the hot fire tests.
Starliner saw good burn performance on B2A2 and S2A2. We're going to inhibit, fail off, and get those back into the set. That'll restore 6th off control. And we're still assessing the other 2 jets.
Okay, we're standing by. You're going to do the inhibit, fail off, and we'll be standing by for cleanup procedures.
Yeah, good read back.
Drifting out to 265, looks like. You want me to fire forward and maintain closer to 260 or just let it drift?
And Butch, go ahead and sweeten that up to get us back into 255 to 265.
And during the recent hot fire test of the RCS jets that had been temporarily deselected, the hot fire test determined that 2 of the thrusters were still performing nominally. They just happened to have a slightly out of range sensor value. We have sensor value ranges set fairly conservatively, which is part of the reason why we do the hot fire test, to verify that they are still working. Mission controllers are still analyzing the other 2.
B2A2 is back in the set. We have 6th off capability back.
And we do have Butch Wilmore continuing to manually hold the spacecraft at this 260 meter point away from the station.
Starliner, we can go ahead and take step 9 with the following deltas. We want your ADI reference frame LVLH and manual controlled hold reference frame LVLH, then point hold, transpulse.
LVLH, point hold, transpulse. And we'll put that to work now.
Good read back. And once you're there, go ahead and sweeten up your pointing to get it back at the target. S2A2 is back in the set. We're looking at the data for the other two jets. Say again, Sonny?
You want us in trans-false point hold, is that correct? Or auto?
No. Yeah, point hold, trans-false.
We're there?
See it. All right, Butch and Sonny, we're ready for the manual piloting demo at your leisure.
I think I got all axes there, Houston. I'm good with manual piloting. As expected, except for when we didn't have the full 6 knots.
All right, yep, we're just confirm you got all axes and you're happy with it, and we're still looking at the data down here. I'll get right back with you.
And as teams continue to analyze the data they've received from those hot fires of the 4 RCS, or Reaction Control System thrusters, they gave the crew the opportunity to conduct the manual piloting demo. They are still at that 260-meter hold point. This is where the demo was initially intended to take place, and due to the station keeping that they've already been performing during these thruster firings, Butch Wilmore reports back that he feels like he has a good idea of control of the vehicle, and he feels that the manual piloting demo itself is complete. And we have been tracking a docking at 11:15.
We've recovered enough jets to get back. Enable 1. Enable 1 is good. I'd like you to configure backup for Enable 1.
Enable 1 on, enable 2 off.
Roger.
We were tracking an initial docking time of 11:15 a.m. Central Time. However, that is a window. That was just the first opportunity. So even this extended hold, we still have the opportunity to make that first docking window.
Starliner is continuing to station keep out in front of the approach corridor for ISS, as both ISS and Starliner are about to enter a period of darkness. Sun going over the horizon for them.
And just as expected, they have entered that orbital nighttime. The International Space Station sees 16 sunrises and sunsets a day, and the orbiting laboratory and Starliner are currently flying approximately 258 statute miles over the Seychelles.
Starliner Houston on the big loop. So here's the deal right now. We are zero fault tolerance to 6th off control, so we cannot technically get into the keep out sphere. However, we would like you to go ahead and fly us in to 200 meters and station keep at 200 meters under manual. And for reference, the attitude that we're targeting is going to be roll pitch yaw 179, 173, and 4. And you're good to do that now.
Roger. Still some discussions here in mission control with engineers looking at the data from the hot fire test. In the meantime, they're having Butch and Sunny move Starliner to a slightly closer position as they await the results of the analysis from the hot fire test.
The vehicle is still being manually piloted, and we heard the call that they do not have the go to enter the keep out sphere due to the current configuration. However, as Jim mentioned, they are flying into near that 200-meter point. The keep out sphere is a 200-meter radius around the International Space Station, sort of an invisible boundary. Keep out sphere and that 200-meter radius, again, it's a way to govern the arrival and departure of vehicles. Essentially, before a spacecraft can enter the keep out sphere, it has to be at least 4 orbits safe, meaning if it were to lose control of its thrusters, it would not enter that 200-meter radius within 4 orbits. again to keep you updated on where we are at. We are troubleshooting 4 reaction control system thrusters on the service module of Starliner. At the 260-meter hold point, the crew was scheduled to conduct a manual piloting demo. They did so by station keeping while those 4 thrusters were hot-fired, meaning they're trying to regain use of them. We've received confirmation 2 of those have been recovered, and they have instructed the crew to move into the 200-meter point. Currently, the crew does not have the go from the teams to move into the keep-out sphere and continue its approach to the International Space Station. We were anticipating docking at as early as 11:15 a.m. Central Time. We will not make that timeline, but we are still in a docking window.
To recap the last few minutes of what we've been seeing here in the Starliner flight control room. Starliner crew, Butch and Sunny, did some manual station keeping, as well as helped do a hot fire test for some of the RCS jets that were automatically taken out of the set for use. Currently, 2 of the 4 that had been preemptively turned off are now turned back on. They saw good data from them from the hot fire test. There's a lot of chatter on the back loops from mission control and the engineers. They're currently discussing a few more of them. Since the hot fire test, Butch and Sunny moved slightly closer to in the approach corridor. All this preparing for the next phase once they finish the analysis of the RCS jet data.
Starliner Houston on the big loop. See you in the hold box. If you can just station keep there, 200 to 210.
If you're just joining us, we are covering the first flight test of astronauts to the International Space Station aboard Boeing's Starliner spacecraft. This is NASA's Boeing crew flight test. The crew lifted off yesterday at 9:52 a.m. Central Time and is currently about 200 meters away from the International Space Station and holding. They do not currently have the go to enter the keep-out sphere and proceed with the docking process, as they are troubleshooting some reaction control system thrusters that failed on the service module. Aboard the Starliner spacecraft are NASA astronauts Butch Wilmore as commander and Sonny Williams as pilot. They are currently manually piloting the spacecraft at that approximate 200-meter hold point.
Re-enabled B1A3, talking about our next approach. Just give us a few minutes.
Bye.
And flight control teams here in Houston have re-enabled the B1A3S service module RCS jet. Butch and Sonny still station keeping Starliner, hovering between 200 and 210 meters out in front of the approach corridor for the Node 2 forward Harmony node docking port.
A little more info about these RCS thrusters. These are reaction control system thrusters. There are 28 of them, and they are located on the service module. That's the lower portion, essentially, when you look at Starliner. The service module does not return to Earth. Also on the service module are 20 OMAC thrusters. That stands for Orbital Maneuvering and Attitude Control. OMAC thrusters are used for larger burns. Meanwhile, the RCS thrusters, what we are currently troubleshooting, these are used closer to the International Space Station. They allow us to make more fine-tuned changes to the spacecraft's trajectory.
ISS. Still some analysis being done on the data from that fire test, as well as determining which docking window may be available for Starliner. Once they have...
Houston on the big loop. Just be advised, looks like you're doing great flying there in the hold box. We lost the first docking window. We're going to still analyzing all the data and getting a path to approach for the next docking window.
That call to the crew from Capcom Neil Nagata here in the White Flight Control Room in Houston, Texas at the Johnson Space Center. We were anticipating the earliest docking today for 11:15 a.m. Central Time, but with that call, we will not be making this first docking window. The second of those windows opens at 12:33 p.m. Central Time.
And just so you're aware, we deactivated Mustang to help out main B power margin.
So we're going to power off the Starline camera for now. We've got to get Vestas.
There we go with that.
The crew is just outside that 200-meter keep-out sphere from the International Space Station. And Butch Wilmore continues to manually pilot the spacecraft.
Starliner Houston, we'd like to get back at some level of automation for the hold. So we'd like to take a destination B, retreat 200 meters, then trans-auto and point auto. And we're just sit tight here for a minute.
Okay, you want to do that now or sit tight?
No, I'd like you to take those actions now. Destination B, Bravo, then trans-pulse, trans-auto, point auto, and then what I was saying is we'll sit tight at 200 meters while we're taking a look at the data and getting a path back in.
Okay, we covered that. We're going to go destination Bravo, retreat to 200 meters. Then we're going to go point auto first, and then trans-auto.
Yeah, sounds great.
Capcom Neil Nagata flowing up some information to Butch and Sunny. They're following a short procedure to get Starliner back into autopilot mode.
Expected message, T2A2 is not where we're looking.
Copy, stand by.
Starliner, yep, T2A2 failed off, still have fault tolerance fixed off control.
Copy. I'm not going to try to figure this out myself. Are we still good at Enable 1? Backup control?
Stand by. All right. Butch, with S1A1 and T2A2, both enables are degraded, so you might as well leave it enable 1. And like we talked about last night, if you have to drop the backup, you'll just have to find the right switch to accomplish what you need to accomplish.
That's what I figured. Thanks. Got it.
You're watching live coverage of NASA's Boeing crew flight test to the International Space Station with NASA astronauts Butch Wilmore and Sunny Williams aboard the Starliner spacecraft. We were tracking an initial docking time of 11:15 a.m. Central Time. We will not dock during this during this current docking window. The next docking opportunity opens at 12:33 p.m. Central Time. That window closes at 1:19 p.m. Central Time. The crew is currently backing away from the 200-meter radius known as the Keep Out Sphere at the International Space Station. They will hold at about 250 meters away. About 45 minutes ago, the teams noticed there were some reaction control system thrusters. These are on the service module of the spacecraft. 4 specifically were beginning to fail off, meaning they would need to be reactivated. The crew took manual control of the spacecraft at the 260-meter hold point and conducted some manual piloting while those 4 reaction control system thrusters were fired. With the current configuration, the teams have not currently given the go for the astronauts and the spacecraft to move inside the Keep Out Sphere. That Keep Out Sphere is a 200-meter invisible radius around the International Space Station, and the spacecraft must be considered 4-orbit safe, meaning it would not move into that radius within 4 orbits if it were to lose control of its thrusters. We are operating out of 2 flight control rooms here at Johnson Space Center. On the left, you see Capcom or Capsule Communicator Neil Nagata. He's the voice you've been hearing speaking with Butch and Sunny aboard Starliner. We're in the white flight control room. This is the Starliner flight control room. And on the right side of your screen is the International Space Station flight control room just across the hall, where teams are leading the space station and all of its systems.
Starliner and Station Houston on the Big Loop. Right now, Starliner has enough capability. We have fault tolerance of 6-off control to press in. However, we'd like to do that press in about 17 and a half minutes from now. Given that, we're going to go ahead and perform another hot fire to see if we can recover the T2A2 and S1A1 jets in the intervening time. So for Starliner, once we get into insulation here and get our optical cameras back for Vesta, we're going to get back into the SM hot fire test procedure.
Starliner copies. Sunny's pulling it up.
Station copies.
That call from Capcom, Neil Nagata to Butch and Sunny and Starliner. They have analyzed the data from the RCS thrusters they've gotten back, the ones that have been enabled. They do have 6-off control of Starliner, which means they are currently go for a docking. They're currently planning on moving in for the next docking attempt.
Again, that next docking window opens at 12:33 p.m. Central Time. In the meantime, they are going to conduct a couple more hot fire tests to continue attempting to recover 2 of those RCS, or reaction control system thrusters.
We are reaching the end. We are reaching the end of the nighttime period for ISS and Starliner. We should expect some views of both Starliner and ISS from each other's cameras shortly. There is a possibility to hot fire some of the jets again during this time period. We will wait for a call from the Capcom.
Starliner for the hot fire. The plan here is we're going to hot fire 3 jets, B1A3, T2A2, S1A1. Part of the reason we have to go back and take a look at B1A3 is because we had an attitude correction. We told you to do it, and it kind of muddied the rates for B1A3. So to get confidence back in it, what we're going to do here is we're going to have you go, go to point hold and manual, right? And then we're going to sweeten up the station keeping. We're going to go to free drift, and then we're going to go ahead. I'll let you know when we start firing those jets. You'll be hands off until I tell you you're hands on. How copy?
We go hands off the 10-minute hands on after we go free drift. We're ready.
Okay, and also to make things a little simpler, we're going to stay in LVLH for this one. So stand by for my next call to get us configured.
Standing by, yeah, we like LVLH. We were curious why we were in Nurse to begin with. Thank you.
Starliner will take a point hold transpulse when you get there. Stand by, Ray will give us some words to sweeten up the station keeping.
Okay, we are point hold transpulse.
This view coming from
Let's
the
go ahead and give us
International.
2 ups. All right, Starliner, we'll take point free, hands off.
Free, hands off.
Again, this view live from the International Space Station, and you can see Starliner still at that approximate 220 to 250 meter point. The space station and Starliner are entering into an orbital daytime, currently flying 259 statute miles over French Polynesia. Of course, we've been keeping you updated with all of the Starliner updates here in the White Flight Control Room, but my teammate Gary Jordan across the hall has been keeping tabs on everything space station. We'll go to Gary.
Heard a jet fire on board.
Roger.
And this is Mission Control Houston. Of course, we're following along every step of the way with the teams over in the next flight control room, following Starliner operations. Some of the views you were seeing were of the flight director, Vincent Lacourt, speaking with Ed Van Cise, flight director over in the Starliner flight control room, coordinating on entering that keep out sphere. We've been showing you periodic views of some of the telemetry that shows that sphere. Now, of course, once we cross that boundary, we're of course now in integrated operations, but that boundary needs to be carefully coordinated before pressing in and make sure it has the right fault tolerance. Outside the keep out sphere now, Butch and Sunny remaining in a hold position. That go to proceed inwards has been given by the teams confident enough in the configuration of Starliner with the necessary redundancies to back away if needed once inside the keep out sphere. Lots of coordination happening on both sides before giving that call. But from the International Space Station flight control team, there is enough confidence in the configuration to go ahead and press in. And we're following along with these views from the International Space Station. Getting great views, the sun reflecting.
Starliner will take point, hold, and then point back at the target, please.
Take hold, and we will point back at the target.
Good read back.
point hold of the Sarge, Sarge being one of the features of the International Space Station. The Vestas system, which we've been talking about on Starliner, tracks some of the features of the International Space Station, just making sure the pointing is right, and we do have some time to figure it out. Again, there's another about 8-minute window before the crew is given the go to press inside the keep-out sphere. Now there are several milestones once we press inside the keep-out sphere to enable a docking, the window of which starts at 12:33 p.m. Central Time this afternoon. But once inside the keep-out sphere, the crew is scheduled to have a 10-meter hold point. We're not pressing in straight from the current position, just outside, just about 200, a little inside 220 meters right now from the station's forward port.
That's okay with you, and otherwise it's just...
Good with the attitude. Point free, hands off.
Attitude point free, hands are off.
S1A1 fired.
Limited jet fire.
Roger.
Capcom Neil Nagata in the Starliner flight control room. The voice you're hearing inside Starliner is Sonny Williams, confirming that when the ground teams enable the thruster firing for that hot fire test, which had been reported to the crew.
Negative. We're firing B1A3. Stand by.
These numbers you're hearing are the specific thrusters.
And we heard it.
Roger that. We're looking.
You heard confirmation of feeling some of those thrusters, S1A1, B1A3. There's the specific thrusters that are targeted for these hot fire tests before proceeding into the keep-out sphere. Again, the teams are comfortable with the current configuration with some of the reaction control thrusters. In the current configuration off. However, some of these thrusters that are being fired now are part of the hot fire test to try to recover some of those. Even though there is redundancy, recovering those would just add enough redundancy or additional redundancy outside of the already go configuration. The crew reporting that they are feeling those thrusters as they are hot fired.
Okay, we'll take point hold to get us back on target track. Point hold and take us back and point us back to the target.
Okay, we'd like to do translation.
Stand by. Starliner, your go to translate back to the hold box manually.
From the view of the space station, you're looking at Starliner, a little more than 220 meters away. The crew has been given a go to switch back to manual mode and push in just a little bit to the hold box before pressing in. Team's continuing to analyze the hot fire test. And we're tracking and following along with the teams before going ahead to press in. From this view, in the orbital daytime, you can see some of the RCS jets firing. as crew takes manual control.
Say again, Tony.
Now back in the box.
And can you guys get us in 200 to 210 meters, please?
200 to 210.
Starliner crew confirming. From the ground, they just need to push in just a little more from where they are. An extra 10 meters or so should get them inside the box, the planned hold box. Again, and they'll continue to hold there. Right now, the crew on manual flight and continue to hold there until given the go to press inside the keep-out sphere. We're just a few minutes away from the scheduled time that the crew is scheduled to depart inside the keep-out sphere. We'll follow along with the teams as they give that go. This is Mission Control Houston. You're getting live views from the station of the Starliner, Butch Wilmore and Sonny Williams inside, manually piloting the Starliner in a station keeping hold position. Right now, just about 212 meters from the station. Station and Starliner are flying approximately 257 statute miles over the Pacific Ocean, approaching the west coast of Mexico, about to fly over the Midwest of the United States on a northeastern trajectory. In an orbital daytime, you're getting great views from the outside of the station. Teams continuing to analyze the Starliner before going ahead and pressing in to the keep-out sphere. The earliest window to do so is crossing right about now, but we'll wait for that go from both teams concurring to press in and go through those next steps to the 10-meter hold point. We'll get that view of Starliner a lot closer than what we're seeing now. We're attempting right now the second docking window, continuing to look at the Starliner and its systems, the reaction control thrusters that are needed to enable a go to proceed inside the keep-out sphere and ensure a safe docking to the International Space Station. The window for that second attempt opens at 12:33 p.m. Central Time. That's, of course,
Starliner Houston C in the box. We'll take auto.
Auto.
Crew manually flying again and station keeping within the hold window inside, right now inside 210 meters. Given the go to switch to auto hold mode, giving Butch and Sonny a break from stick time, holding in that position before proceeding inwards towards the keep-out sphere. Again, we were talking about the windows. 12:33 is the beginning of that window. 1:19 p.m. Central Time is the back end of that window. flight controllers here in the International Space Station Flight Control Room, continuing to evaluate steps needed to ensure a go to proceed inside the keep out sphere, and go ahead and press in for that attempting for docking within the second window. We're following along very closely and coordinating.
Houston. So based on the hot fire tests, T2A2 and S1A1 had satisfactory results. We didn't get a result out of B1A3. So we're going to re-enable T2A2, S1A1, and inhibit B1A3.
We copy all. You're going to inhibit B1A3. The other two, we see one of them back online, and it felt like the rest of them to us. I'm not sure what your data shows, but okay, copy all.
Okay. Just read that back. You felt all three.
Yes, we felt all three.
Roger. And by getting back T2A2, backup enable 1 became full again. And I don't think you switched out of that, but we're still go backup enable 1.
After that, enable 1 on, enable 2 is off. SMRCS.
Roger that.
So again, holding outside the keep out sphere, Butch Wilmore, Sonny Williams inside the Starliner spacecraft, working hand in hand with the ground controllers here, or the flight controllers here in Mission Control Houston, specifically the Starliner flight controller room in the room next door to the International Space Station flight control room. The teams worked together to hot fire some of the reaction control thrusters that went down. Looks like some of the reaction control thrusters, 2 specifically, performed well, so those will be re-enabled. 1 did not perform so well, so they're going to go ahead and inhibit that particular thruster. That one's B1A3. Currently analyzing the configuration before pressing in. The flight control team here in Mission Control Houston, the International Space Station flight control team, working hand in hand to make sure that we are jointly operating within the flight constraints needed to press inside the keep out sphere. Flight Director Vincent LaCourte here in the International Space Station flight control room, working hand in hand with Ed Van Cise, the flight director in Starliner Mission Control. We're continuing to follow along here in the International Space Station flight control room. Let's go ahead and head over to the White flight control room with the Starliner teams following along.
Starliner,
Leah and Jim.
To recover. It's an OrbTraj tab stop 8 for recover.
Stop. Hey, recover. Here we go.
Thanks, Gary, and welcome back to the White Flight Control Room here at Johnson Space Center. Yes, we are monitoring Starliner here in this room, all teams continuing to analyze the data from the recent tests. And as you can see, Starliner in this live view from the International Space Station, it is essentially parked at about 200 meters away from the station. Again, we are waiting to move into the keep out sphere, that 200-meter radius around the space station. We are targeting the next docking window that opens at 12:33 p.m. Here's another good look at the teams in Mission Control Houston, both Starliner and International Space Station. As Gary just shared, over there on the left, in the middle of your screen, that is Neil Nagata. That's the Capcom you've been hearing speak with the crew. Down toward the bottom in the white shirt is NASA astronaut Mike Fink. You may have seen him on the launch broadcast yesterday. He is also a crew member for the Starliner 1 mission. Up at the top of your screen, that's Flight Director Ed Van Cise.
And Starliner progressing slowly through the approach corridor now. We've just reached 187 meters. 190 meters, the first distance in Starliner's flight plan for docking. First milestone inside of the keep out sphere. currently moving towards station at about 23 centimeters per second. We're going to continue our slow approach until the 10-meter point at which we have a planned hold, where we will enable the NASA docking system, NDS, and then prepare for a final docking several minutes afterwards.
Starliner is directly lined up with the Node 2 forward port. That is where it will be docking today. Also docked to the Node 2 port are the SpaceX Dragon spacecraft. That's on the zenith side. So once Starliner arrives, we will have 2 American crewed spacecraft at the International Space Station.
Station Houston on the Big Loop. The Starliner is inside the keep-out sphere. Begin monitoring per 1.106, step 1.1.
1.1, 1.106, stay tuned.
And with Starliner inside the keep-out sphere, this is the second of those 2 invisible boundaries that we use to govern arriving and departing spacecraft. The first is the approach ellipsoid. That's when our joint operations begin between the space station and the Starliner teams. Now, the keep-out sphere, we had to wait outside of this location for a go. You have to have at least 4 orbits safe before you can move into the keep-out sphere. That means if you were to lose control of your thrusters, you would not move inside that boundary for 4 orbits.
Just to make sure we're on the same page, we're inside the keep-out sphere, and we are in procedure 6.102, step 28 with you.
And Starliner is with you. Light fill 2's up to 45 hits.
And Barry, that is as expected. Those will reject up until 10 meters.
As Starliner continues its approach, both it and the International Space Station are flying approximately 261 statute miles over Kansas, crossing into Nebraska. Another satellite handover as Starliner continues its approach to the International Space Station. Again, we track these handovers on the tracking data and relay satellite system, and we have regained that visual communication of Starliner on its approach. Again, we are inside the keep-out sphere. Starliner has been given the go to proceed, and we are targeting the earliest docking time for 12:33 p.m. Central Time.
And Starliner Looking good on our current rates in. We're expecting about a 6-minute lighting hold when we get to 10 meters.
6-minute lighting hold, copy.
Capcom, Neil Nagata, providing some status updates to Butch and Sunny up in Starliner. They're still progressing slowly towards the 10-meter hold point. Currently right at around 109 meters away from the Node 2-4 docking port, progressing at about 21 centimeters per second. Once Starliner reaches the 10-meter holding point, it will hold for about 6 minutes to wait for nominal lighting. Part of the reason for that hold and the nominal lighting is to get enough sunlight in the right direction to help Starliner's Vesta cameras view all of the features of ISS for part of the image recognition part of the Vesta system, as well as it also helps the ISS crew continue to monitor Starliner from their side.
And just a reminder of the NASA astronauts aboard Starliner today. Commander Butch Wilmore, it is his third flight to the International Space Station after having been selected as an astronaut in 2000. He flew first to the International Space Station as a pilot on Space Shuttle Atlantis in 2009 and served as a flight engineer for Expedition 41 in 2014. NASA astronaut Sunny Williams is the pilot for the CFT mission, or Crew Flight Test. She was selected to be a NASA astronaut in 1998. This is also her third flight to the International Space Station, the first one coming as a flight engineer for Expedition 14, and in 2012, a member of Expedition 32. Starliner is now approximately 90 meters away from the International Space Station.
And at the 100-meter point of Starliner's approach towards ISS, it has slowed down to 0.1 meters per second, or 10 centimeters per second. It will continue at that lower rate until it reaches the 10-meter holding point.
And to recap, we are again targeting a docking no earlier than 12:33 p.m. Central Time. This comes after some troubleshooting of some reaction control system thrusters. Those are also known as RCS thrusters on the service module portion of the Starliner spacecraft. We had five at different points, had five of those thrusters go offline, and through several hot fire tests, we were able to bring back four of those thrusters and obtain the go and the redundancy that we needed to enter the keep out sphere and approach the International Space Station for docking.
Passing through the 80-meter mark on Starliner's approach to the Node 2-4 docking port, we'll expect another decrease in velocity. Right around the 50-meter mark, we'll cut it in half, down from 0.1 meters per second to 0.05. then further, when we get to the 30-meter mark, we will turn on Starliner's forward docking lights.
Starliner now approximately 63 meters away from the International Space Station. Again, we are docking to the Node 2 forward port today. We are now 33 minutes away from the opening of the next docking window. However, we may hold at the 10-meter hold point for lighting to balance out and give us a better view of the international docking adapter that Starliner is targeting. Starliner continues to use the Vistas system as it approaches the International Space Station. That stands for Vision-Based Electro-Optical Sensor Tracking Assembly. There are 2 Vistas on Starliner so that we have fault tolerance. These include vision-based cameras, a long-wave infrared camera, as well as LiDAR.
Starliner just passing the 50-meter mark. It has now slowed its approach rate to 5 centimeters per second, 0.05 meters per second.
Starliner continues to approach the International Space Station. Both are traveling at approximately 17,000 miles per hour, but in these proximity operations, we have to move very slowly and precisely to line up properly with the Node 2 forward port. We are now about 44 meters away from that docking adapter. The next hold point comes at the 10-meter hold point. And again, we anticipate that we may hold here for some time while we wait for the lighting to balance out for Starliner.
Station still progressing at about that 0.05 meter per second approach rate. Starliner currently experiencing a period of relative darkness where the visual spectrum cameras aren't getting as much information from its picture, but the LiDAR and infrared cameras are taking over for most of the data capture.
Again, this is NASA's Boeing crew flight test to the International Space Station, the first flight of astronauts aboard Starliner. Today, they are carrying NASA's Butch Willimore and Sunny Williams, both making their third trip to the International Space Station after lifting off at 9:52 a.m. Central Time yesterday from Space Launch Complex 41 in Florida. And we are coming up on 30 meters from the International Space Station, getting a beautiful view now of Starliner as it continues its approach. We are in an automated piloting mode at this time, so the crew is not having to command the spacecraft. Starliner is designed to automatically rendezvous and dock with the space station, but we have seen the crew take manual control of the spacecraft a couple of times during this flight test. One of those happened yesterday afternoon while we were in what is called far field operations. They essentially got to test maneuvering the spacecraft in case they ever did need to take manual control. And because that test went well, they did the same thing as we were at about the 260 meter hold point earlier today.
just passed through the 30-meter mark, and you see the Starliner's forward docking lights turn on. Station is getting a good view of Starliner with the lighting coming from that direction. We're waiting for the Earth to spin a little bit more, sun to move relatively, so Starliner gets a good set of lighting on station, and we'll continue the approach towards the Node 24 docking port. Starliner nearing the 20-meter point, currently at about 22 meters away, still progressing at 0.05 meters per second. From Starliner's view, front of station is still fairly dark, using mostly the LiDAR sensor for feature tracking on the front of the docking Node 24 docking port. Currently, you can see Starliner's NASA docking system, NDS. Docking cover has been open for a long period of flight. Currently, the docking ring on the soft capture system is retracted. It's the inner metal ring on the front of NDS with the 3 pedals sticking out from it. Once we hit the 10-meter docking hold point, Starliner will extend the soft capture system, which is a series of motor-controlled arms. Once we start moving forward after the 10-meter hold point, those arms will remain extended. Starliner will approach the International Docking Adapter. Upon contact, there are several spring-loaded latches that will attach Starliner to station. Then, several minutes later, the arms on that soft capture system will retract. From there, there are several hooks that will securely latch Starliner onto that docking port, and then from there we will have hard capture. Right now we're currently coming up on 16 meters away.
And again, we anticipate holding holding at that 10-meter hold point. This is a built-in hold, and we may wait here until we get ideal lighting. The International Space Station and Starliner are flying over Algeria and about to cross into an orbital nighttime. Again, we see about 16 sunrises and sunsets each day when traveling at orbital velocity. That's 17,500 miles per hour. In terms of relative velocity right now, Starliner is traveling at about 0.05 meters per second. And to translate that, that's about a tenth of a mile an hour as it moves in toward the International Space Station.
Meter hold confirmed.
Houston copies, and Starliner, we're expecting 6-minute lighting hold before NDS configures for docking. Station Houston on the big loop. Starliner's at the 10-meter hold point. ISS crew perform 1.106, step 1.2.
Station copies on the big loop. Executing 1.2 of 1.106. ISS crew ready for final approach.
Houston copies. Starliner Houston, got your fill-ins for your step 31. The maneuver to target align will be at 17:27:40. Expect final approach at 17:30. We're going to have 47 minutes of margin.
Okay, 17:40 and final approach 17:30. We don't know if you said 40 or 00.
It was going to be, the time for final approach 17:30:00 with 47 minutes of margin. 47.
Okay, 00 with 47 minutes of margin. Copy.
Starliner holding steady in the 10-meter hold point. Currently about 3 minutes and 50 seconds away until for the first phase of the 10-meter hold. We're waiting for better lighting for Starliner's cameras. In the second phase of the 10-meter hold, the NASA docking system will continue to finish its initialization.
Starliner appears suspended in space as it and the International Space Station continue traveling at over 17,000 miles per hour. And again, we are anticipating an orbital nighttime here shortly. We are at the 10-meter hold point. This is a built-in hold for all arrivals. And we will continue holding here until we get the lighting that the teams are looking for to continue to press in towards that node 2 forward port.
With this close-up view, you can actually get a pretty good view of what the Vesta cameras look like and where they are. Those are the two black rectangular shapes in the upper right and bottom left of that front docking port area. There's also an additional camera offset to the left, just above the orange data connection. Those cameras are spread out in different locations to help better track different features on the front of the international docking adapter.
And data relay satellite systems, and we expect to regain visual communication shortly. However, we will still be at that 10-meter hold point. Again, the docking window opens at 12:33 p.m. Central Time. And we are in an automated piloting for the Starliner spacecraft, so Butch and Sunny are able to continue monitoring its approach once we resume that, but they will not be needed to take manual control and fly in and dock the spacecraft. That capability does exist, and we tested some of that manual piloting earlier in the flight.
Houston, we just hit 10-meter hold 2. We're putting step 32 in work, if you're ready.
We are ready.
Again, Houston.
We are ready.
Okay, here goes, step 32.
Roger.
All right, NDS latch NEA switch is in enable.
Roger. Starliner reactivating Mustang.